All right, here we are. Welcome to Standing For Truth. My name is Donnie, and this is Matt, and we are going to be covering young Earth creation and testable predictions in this very important video. Which model, the young Earth creation model or the evolutionary model, meets the gold standard of science? Which model makes the best testable predictions? And we are here to cover this topic very comprehensively. Isn't that right, Matt? Good to have you, brother.
Thanks, man. Yeah, we're going to cover a lot tonight, most likely, depending on how long we've got, right?
Well, what we'll probably do is a two-parter or possibly a 20-parter. We have so much information, and people are probably wondering, why are you guys doing this so late? Well, we've got so much content and so much work that we're doing throughout the day, every single day. This has been the summer of all debates. And so we've wanted to do a specific show on testable predictions for a little while now. So originally we were going to, I was wondering what's going on there. So we wanted to do this for a little while now. We were going to pre-record it, but what we'll do is air it right now. And then we'll also premiere it over on our secondary channel, Young Earth Creation. So Matt, before we get right into it, what's going on, and maybe just a real brief introduction in terms of why this specific topic's important.
Yeah. I've been not making too many long videos lately because I've been trying to get this presentation ready to go, and not just this one, but another one as well. And the reason this subject is so important is because we need a head-to-head comparison of what actually is the better model. And nothing is better than a head-to-head, active, novel, proven, testable predictions that have been made against one another. It's the best way, because when you get people that are really opinionated, it really doesn't matter. You guys can argue and bicker back and forth until you're blue in the face. And it's like fighters. You see them all the time. They're yelling at each other. I'm the best. No, I'm the best. I'm the best. Well, guess what? It gets settled in the ring. And that's easy, right? We can literally watch it happen. Well, in the science realm, it's settled by how many testable predictions have been made that are novel, accurate, and come true. And when it's put head to head, which one is better at explaining the diversity of life that we see in the world today? Which one is actually true? Is the Bible the history book of the world? Is what it says testable and predictive? Does it have true history value? And when it's compared to evolution, which one is actually true? So that's why this this subject is so important, and why we need to teach you guys that these arguments are so good and how to use them and why to use them, that they are a very good arguments to give to a critic, because as you guys know, talking to a critic about the Bible isn't going to get you very far, because everyone's already critical of it. But when you meet them on their level of science, which they already believe to be true, and you're arguing with their favorite subject, they're more prone to listen to you. And then when you convey the information to them and you convince them with their own subject that they like, then you've won them over. And that's what we try to do. We're here for the Christians to give you guys good answers, and we're here for the critics to show you, no, we have the better model.
Right. We're here to show them the superior model in terms of origins. And this specific video, as I've mentioned earlier, it's going to be comprehensive, and we are going to demonstrate what real testable predictions are all about. Okay, not these failed testable predictions, so-called testable predictions coming out of the evolutionist side, like the so-called chromosome 2 fusion. And I'm sorry, evolutionists, okay, you don't get highly functional genes by slamming together two chromosomes. And these so-called predictions when it comes to the fossil record, right, Matt, where you've got so-called predictions on tectonic, but then you get true tetrapod foot tracks discovered that predate, according to the evolutionary model, 20 million years from where Tiktaalik was found. So no, we're actually going to be covering real testable predictions. And the evolutionists, they constantly have what's called egg on their face, okay, where they have a lot of assumptions. They put forth a lot of arguments like junk DNA and pseudogenes. And then years later, we discover that those arguments, that position is premature, and it's the creationists making the best testable prediction. So what I'm going to do is just kind of get right into it. I've got a few things to cover. Matt will get your input as well, and just kind of have some fun. Matt, you and I, we in this ministry, of course, we've written a number of books. And we like to focus primarily, I'm looking over there at the Endogenous Retrovirus Handbook, for example. I've made some novel predictions there, which I'm going to touch on in this show. Predictions pertaining to fixed ERV sequences versus unfixed ERV sequences, and predictions on DNA function, so on and so forth. But for now, I want to focus on some confirmed predictions from the young Earth creation model that have come out from other fields of science, like geology, astronomy. What's important to understand, guys, is when it comes to the young Earth creation starting point, we have ample amounts of scientific evidence in all fields. Okay, Matt and I, we prefer. We like to focus on the genetic data because we like to focus on the direct lines of evidence, right? We oftentimes point out it's genes, traits, and genetics that are inherited sperm and egg, not a rock, not a fossil, not geography, but genes and traits that are inherited sperm and egg. And that's where we can, I think, best answer this question of ancestry. And so why I'm reiterating this is because, as I've pointed out, we've written a number of books on the separate ancestry model, and we've put forth numerous scientific predictions, as well as just a great multitude of retrodictions coming out of the realm of genetics, which, Matt, I know you're going to touch a lot on during your presentation here. So I want to focus on this one specific prediction from geology. Okay, and then I'm going to, Matt and I, we're going to spend just 10 minutes, not really that long, refuting an argument from good old desperate Stern Cardinale. And I say desperate because the arguments that he's still putting forth have already been dismantled over and over again. And then we're going to get into, Matt's got a lot of visuals and stuff here too. So here we go. I'll just get right into it. So testable predictions. Actually, Matt, I hear slight feedback. I wonder if it's if you click mute real quick. Let's see if I can hear it.
That was probably me. Hold on.
Oh, well, it could have been a fan actually in the background.
It was.
Okay. No, yeah, because I don't hear it anymore. So okay, good, perfect. Okay, so as you guys can see here on the slide, okay, we've had not only future testable predictions, which, Matt, as you know, we're going to touch on a lot of future testable predictions that we don't necessarily have an answer to, right? We made a prediction on mutation rates. We made a prediction on DNA function, and future observations, future experiments will tell us if these predictions are true or false, right? And that's going to dictate the strength of our model. That being said, the young Earth creation position has also had predictions made in the past that have been confirmed and have come true. Okay. And not just in genetics, but in all fields of science. For example, here's just a few. The strength of several planets' magnetic systems. Dr. Russell Humphreys, he's predicted that. And they've come true. Helium in Earth's rocks. The presence of radio halos in metamorphosed sandstones, cold material from Earth's crust near the Earth's core. This is the one I'm going to really want to focus on because, Matt, you know, we could spend 3 hours on each one. Okay, so I want to focus on just one specific one here, but there's also been predictions on the rapid reversal of Earth's magnetic field. So again, this is going to be a two-parter, so we will touch them all eventually, but this is the one I want to focus on here. Cold material near Earth's core. Okay, so I kind of want to give an overview here as to why this is important. Okay, because the uniformitarian model would hold to plate tectonics, as we all would, right? The plates are certainly moving, but they would hold to the snail pace movements of the plates. They reject a global flood, right? 2 Peter 3. In the last days, there's going to be scoffers denying the world that then was being overflowed with water perished. This is also a problem that the old earth creationists and the theistic evolutionists have, including the naturalistic evolutionists, the atheists, because they can't address the successful predictions that have come out of what model? Not the uniformitarian model, but the flood geology model. And we actually have overwhelming evidence that not only have the plates moved in the past and are currently moving slowly today, but that they moved rapidly in the past. Okay, this is called catastrophic plate tectonics. And the Bible tells us clearly that the fountains of the great deep broke forth. Okay, therefore we'd have plates moving vertically, we'd have plates moving horizontally, we would have continental sprint, not continental drift, but continental sprint. Meters per second movement of the plates through the floodwaters, okay, rather than the snail-paced movements. And this would have occurred at the time of the flood. Now, we actually have, because the evolutionist crowd, right, they'll say, oh, this is all ad hoc, there's no evidence for this. Okay, well, we know from the Bible that there was a global flood. We know from the Bible that the fountains of the great deep broke forth. But we also have today empirical scientific evidence. We have something called seismic tomography. Okay, and seismic tomography data has actually confirmed continental sprint in the past. And continental sprint is necessary anyways because it's the only explanation for the geologic features of the earth we see today. For example, mountains. And I like to use the analogy, if you have two cars coming at each other at 1 kilometer an hour, there's not going to be much force. There's not going to be much buckling. They're going to hit each other and it's just going to end there. But if you have two cars coming at each other at 120 kilometers per hour, okay, there's going to be tremendous force where the buckling and the impact, the results will be tremendous compared to if it was two cars coming at each other at 1 kilometer an hour. And that's the same thing we see with these mountain ranges. Okay, your snail pace movements through the waters in the earth is not going to create enough force and buckling of the rock strata to uplift these mountains that we see today. But with continental sprint, we would have the necessary force and impact to rapidly buckle the rock strata, producing these mountains. Okay, but where this comes into play in terms of testable predictions is the fact that when scientists look at subducted plates today, you can actually see massive slabs. Okay, massive slabs that go all the way down to, some of them even to the top of the core. We have slabs going down hundreds of miles deep into the mantle. And guess what? They're the same density as they are at the surface. And why this is important is because it implies that they are what? The same temperature. So these slabs happen to be cold. Okay, they're still cold even though they are deep down in the earth where they should have warmed up or even melted. It would be like if I had a coffee here, right? And it was scorching hot. It was hot, the way I like my coffee. And then I went upstairs. All right. Or a better illustration would be if I came downstairs and I had a coffee here and I took a sip and it was cold. Well, I know it's probably been sitting there for a while. Right? But if I came downstairs and the coffee was sitting there and there's still steam coming out and it's hot, maybe hot to the point where I burn my tongue, well, then I know it hasn't been sitting there that long. So the fact that we actually have these massive slabs of cool rock, okay, down in Earth's mantle where they should have warmed up or melted tells us that they've only just been pushed down there recently, within thousands of years rather than millions of years. All right. So again, the fact that they're the same density as they are at the surface, that implies that they're the same temperature. And that's important here, right? These slabs of rock are still cold, even though they are deep in the earth, where again, they should have been cooked at this point. Okay. Continental drift, sorry, uniformitarians, cannot account for this. If they were going down there at snail pace movements, 1 inch per year, they would have assimilated to the surrounding material. Or again, as I've pointed out, they would have been completely cooked. These should be very hot, but we see the same density from the surface all the way down. Okay, and this is where I want to get into the slide here. So prediction 4. Hopefully I've explained it well to make it understandable. Prediction 4. Cold material near the Earth's core. In the early 1980s, physicist Dr. John Baumgardner developed a creationist theory for the rapid motion of the Earth's crust during the flood. His theory suggested that the cold crust located beneath the pre-flood oceans should have sunk the full 1,800 miles to the base of the Earth's hot mantle, where the temperatures are up to 7,232 degrees Fahrenheit, or 4,000 degrees Celsius. This crust would have melted if it had millions of years to reach the base of the mantle, right? As I was explaining, it would have melted or been cooked if it's been, these slabs have been going down there slowly over time. Okay, sinking as slowly as today's rates, these snail pace movements that we see. On the other hand, if it sank quickly, 4,300 years ago, roughly, at the flood, as Baumgardner's theory suggested, then piles of those plates should still be found at the base of the mantle, cooler than the mantle around them. Test result, mantle discovery. So we have a future testable prediction based on a flood geology model, specifically catastrophic plate tectonics. And what do we have? It took 10 more years before scientists developed the technology capable of seeing something, seismic tomography, as I pointed out, like that at the base of the mantle. When that technology was developed, the cold material was discovered. So they discovered this cold material after the model was put forth, after the predictions were made, just as Baumgardner's model had expected. This is as close to proof in science, specifically geology, that you can get. This is as close to proof as you can get. This successful prediction suggests that Dr. Baumgardner's model is true. It also suggests that continents moved rapidly during the flood, right? Fountains of the Great Deep break open. You have continental sprint in terms of these plates. You have rapid plate subduction, where you have one plate going underneath the other, okay, which is exactly why we find these slabs going hundreds of miles deep into the mantle. And yet they're the same density as they are at the surface, implying that they're the same temperature, implying that they had just been taken down there thousands of years ago and not millions of years ago or hundreds of thousands of years ago. Okay, so again, I want to repeat this part. This successful prediction suggests that Baumgardner's model is true. It also suggests that continents moved rapidly during the flood, just as the Bible puts forth. Matt said it perfectly. The Bible claims to be the history book of the universe. Therefore, we should be able to make successful predictions and accurate retrodictions. And we do in all fields: geology, genetics, biology, astronomy, you name it. And that the flood occurred only thousands of years ago, just as the Bible suggests. And the last thing I wanted to put forth on this has a right here. So here's an article dealing with this in more detail. Okay. Oh, here we go. Because the cold pre-flood ocean floor sank only 4,500 years ago, and it would take many millions of years to melt, colder material should still be sitting at the base of the mantle. Think of it like an ice cube in your hot coffee. It'd still be there after a few seconds, but gone hours later. If I put an ice cube in my hot coffee and left the room, and my wife came down, 3 hours later, well, that ice cube is not going to be there. It would have melted. But if it is still there, then that's good evidence that that coffee hasn't been sitting there that long with the ice cube. Not long after, in 1987, geologists discovered evidence that supports both conclusions. Although the mantle is very hot, up to 7,200 degrees Fahrenheit, geologists found slabs of material at the bottom of the mantle that are cooler than the surrounding rocks by as much as 5,400 degrees Fahrenheit. This discovery presents two mountainous puzzles for evolutionary geologists. And I want the theistic evolutionists out there that compromise their Bible. I want the old earth creationists and the atheists to address these problems. First, the 420-mile deep, 670-kilometer barrier seems to prevent plates from getting down to the bottom of the mantle. Second, even if plates could push through the barrier at their present rate of 1 to 2 inches, right, these snail pace movements that we see today per year, they would melt and match the rest of the mantle's temperature. In other words, they would have been completely assimilated to the surrounding material or completely cooked. But yet we find that they're cool. we find that they have not warmed up or assimilated. But the findings fit nicely with Baumgardner's catastrophic flood model. And that's just one. That's just one of the many predictions. Matt, any thoughts on that, brother?
No, that's always a great subject. His predictions were spot on, and like we said, there's no other way to account for it other than it had to happen rapidly. I mean, not a lot of time has passed. So even if for some reason this was very slow and it somehow managed to push itself down, well, guess what? It had to have been recently that this slow movement happened. It's just none of it makes any sense. You can't have it slow and be recent. So It had to be fast to be recent to warm it up. Very simple. The logic is there. I mean,
and this model was put forth years ago. And then I think it was 10 years or so after the model was put forth that we actually had the science known as seismic tomography to even be capable of discovering these cold slabs.
Yeah, it wasn't even called catastrophic plate tectonics. Back when he actually predicted it, it was called runaway subduction. That's what he named it. So he didn't even have the right name for it yet. They came up with catastrophic plate tectonics afterwards. They were still building the entire model. So he was making predictions before the model was even finalized and got them right. So incredible.
Well, you get these guys, right? You get these evolutionists that are like, the young Earth creation model needs to make future testable predictions that are also confirmed. Well, here's just one of the many. Okay. And I still only gave the details. And we've made just a huge multitude of predictions in the world of genetics that we don't necessarily have an answer to yet. Right? We've made our own. Dr. Nathaniel Jensen, he looked at a people group, okay, the Khoisan peoples, whose mutation rate is not yet known. And he literally predicted, he pointed at them and he said, I predict that, when we get the blood and the DNA and we test the rate, it's going to be XYZ. It's going to be X mutation rate. That is an amazing testable prediction. That is like me going to somebody on the street who I've never met, I've never seen swing a baseball bat, and saying, hey, I predict that you could hit a ball, 265 feet. And then it turns out that they hit that. That's a pretty good prediction. You don't get these kinds of predictions from the evolutionist camp, do you, Matt? You get predictions where it's like, well, I would expect a fossil creature that kind of blends the features of these two types of animals, when we already know the biodiversity in the past was immense. I mean, there's billions and billions of fossils. There's been millions and millions of species. So, you know what? It's not impressive when you get a couple lucky guesses, right, Matt?
Yeah, when your theory can predict literally everything, there's no power in that. When you know what I mean? That's what they've done. We're going to get into that. But that picture is actually of his prediction, by the way. That's Dr.
Right here?
Yeah, I found it. And that is what he said,
go.
actually. In 2015, he predicted that.
So right there, to the evolutionist critics, Dr. Nathaniel Jensen, I predict that the most diverse African groups will be found to mutate their mitochondrial DNA at a rate of 2-fold faster than reported here. Example, at 0.2 to 0.3 mutations per genome per generation, rather than 0.16 mutations per genome per generation. So the point is, we have novel future predictions where only future observations and experiments can tell us if they're true or false, right? But we've also got predictions that have been made in the past that have come true. So we've got the best of both worlds. Now, Matt, I know you have a lot to get through. So what I'm going to do is I just wanted to go over that prediction real quick. Now I'm going to play just a 15-second clip from Dr. Dan Stern Cardinale. So I am going to do the audio. I want to address this real quick because, we've been very comprehensive with Team Dodgeball, and essentially they've failed to provide a superior model. But this is a clip from his review of my endogenous retrovirus handbook, where not once in that review did he actually demonstrate or document a non-functional endogenous retrovirus going from non-functional to something incredibly functional in determining cell types, in embryological development, gene expression, gene regulation, cell stress responses, the immune system. So he failed to address the differentiating lines of evidence, unfortunately, okay? But he also repeated, and here's where I'm going to share screen, Matt, we'll get your thoughts on this too. He repeated an argument that we've refuted quite extensively in previous books as well. Here it is. So I am going to mute myself. I'll play it. It's just short. And then we're going to give some of our comments here because it pertains to, in a way, the mutation rates we just talked about. So here we go.
For the record, the argument against created heterozygosity is that the rate of intra-exonic recombination, so the rate of recombination within the coding region of genes, right, the parts that code for amino acids, the rate of recombination in those regions in the genome is too slow, right? That's why created heterozygosity doesn't work. You can't get like the 1,000 alleles or more that we see for some human genes. There are 4 digits of alleles for some human genes. Starting with 4 alleles, no matter how different those alleles are, the recombination rate is just too slow to get all the variants that we see today. That's what the argument is. It has nothing to do with out of Africa. I don't know why this part of the book exists, but it shows that SFT does not understand like this argument at all.
You're muted.
Yeah. Okay. So I just stopped sharing screen. So no, I understand the model or the argument just fine. Matt, as you know, battling these evolutionists for as long as we have, one of their main arguments against the separate ancestry model and design diversity has to do with what? African genetic diversity. Also has to do with Neanderthal phylogenetics, right? Which we've addressed. And apparently there's too much scrambling to them, even though there's not enough scrambling if we want to talk about linkage blocks, right? We can turn it right back on them. It's like, why do we have so many large intact chromosomal text strings that appear to have never undergone gene conversion or recombination if apparently we've been evolving for hundreds of thousands of years and then going back to ancestors like the Australopithecines and then up to Homo habilis, erectus, so on and so forth. That's a lot of generations of recombination. So the genome should actually be more scrambled. But anyways, they want to say there's too many pieces of DNA to be floating around to explain in only a few thousand years. So we've pointed to, and I had a whole section in my book dealing with the PRDM9 DNA element and recombination hotspots, and how we have more of those genes in African populations and therefore more recombination. And so just because a population can harbor more genetic diversity does not mean what? Does not mean they're older. Okay. But then there's another argument that they like to make here where, as Dan is pointing out, okay, we have most of the world's variation is only about 2 alleles. Okay, but there are exceptions. You either got A or C or G or T. And what I'm going to do is just share screen because I do have some slides that are important. Okay, here we go. And this is, I've been working on my special creation book. So we're going to be getting like a fully expanded, updated version. Okay. So anyways, there is an exception to the rule as with almost everything, right, Matt? So again, most of the world's variation is comes in only 2 alleles, which fits nicely with the separate ancestry model. But there are some genes where you can find 800 to 1,000 of them. Okay. But here's the problem is that after creation, and Dan talked about what created heterozygosity, which is just a fancy way of saying design diversity. Okay. Heterozygosity is a state of DNA diversity. It suggests that Adam and Eve and the original created kinds would have been front loaded with pre-existing beneficial diversity, where you have DNA differences within and across. And essentially, Adam would have only needed 10 million variants. And you can explain the world's diversity today. Okay. So that's basically what created heterozygosity is. And then since the DNA differences are already built in, you can get rapid change quickly, because the evolutionary model requires millions of years of mutation accumulation, because mutations add genetic diversity, because mutations are adding something that was not previously there, right? So they need the time to build and accumulate the necessary genetic variation for natural selection to act upon, or for recombination to scramble up, leading to new chromosomal combinations. But according to the created heterozygosity model, you can get novel chromosomal combinations in a single generation, since the DNA differences are already built in. Okay, so after creation, guess what? We have thousands of years now for mutations to occur. And remember, a mutation adds genetic diversity. It's not beneficial diversity. It's negative diversity. It's like the type of diversity, right, Matt? You get on your car. You get a brand new car and you go park it at the grocery store. You want to pick up some, almond milk, but you park too close to somebody and you come back and it turns out they smacked your car with their door. Now you got a nice dent. Okay, so you know what? Your car is a little more diverse, but not in a good way. Okay, so the beneficial diversity that exists in humans and animals, the beneficial diversity would be created diversity. A lot of the negative diversity would be due to mutations over time. Now, we have thousands of years for mutations to occur. We understand that the mutation rate is incredibly fast, much faster than evolutionists ever expected. In the nuclear DNA in humans, it's roughly 100 new mutations per person per generation. The mitochondrial DNA and the Y chromosome, which are the uniparentally inherited DNA compartments, the non-recombining DNA compartments, you could say, they're fast. Here's a paper from 2022, estimates of the mutation rate with a non-phylogenetic approach. Remember, Matt, it's circular reasoning when it comes to the evolutionists, right? They want to assume evolution to prove evolution. They want to use the phylogenetic method rather than the empirical method. They want to assume the geological column rather than basing their the strength of their model on observed mutation rates. So notice this. With a non-phylogenetic approach, namely pedigree analysis, meaning those are the mutations that we can see accumulate and be passed on in real time, are reported to be approximately 10-fold higher than phylogenetically derived rates. This is a paper from 2022. Pedigree-derived mutation rate across the entire mitochondrial genome. Okay, and that's specifically in the mitochondrial DNA. The Y chromosome mutates about 3 per generation. And again, the nuclear DNA, about 100 new mutations per person per generation. You got 7 billion people on the planet. You got 100 new mutations per person per generation. That's 700 billion new mutations in the human population. Okay, so the mutation rate is fast. Mutations are accumulating. And we have thousands of years since the creation event for mutations to occur. We have thousands of years for recombination, right? At creation, Matt, we would have had no mutations, no deleterious mutations, and we would have had more fully functioning and working PRDM9 genes, more recombinational hotspots, therefore more recombination, essentially, okay? So we have thousands of years for mutations, which we know a lot are accumulating, recombination events, and also what the evolutionists rarely want to talk about, gene conversion. Okay, and I've got a bunch of papers here, gene conversion. Crossing over is well known to have profound effects on patterns of genetic diversity and genome evolution. So the evolutionists want to look to patterns of genetic diversity, or they want to look at certain people groups and assume that the genetic landscape of these people groups means that these people groups go back further than just a few thousand years, right? When in fact, we have profound effects on genetic landscapes simply based on rates of gene conversion and recombination. Okay? Far less direct attention has been paid to another distinct outcome of meiotic recombination. okay, meiosis, non-crossover gene conversion. Crossing over and NCGC, which stands for non-crossover gene conversion, both shuffle combinations of alleles. You can get new combinations of alleles through recombination and gene conversion. And this degradation of linkage disequilibrium, which is what LD stands for, has major evolutionary consequences ranging from immediate effects on nucleotide diversity to long-term consequences that shape genome evolution, species formation, and species persistence. Okay, so there's a lot of processes going on, including the rapid accumulation of new mutations that can explain what we see today in terms of genetic landscapes in people groups and in species, as well as levels of genetic diversity, whether it's higher levels or lower levels of genetic diversity. Okay, many alleles we see today appear to be mutation related. I want to point that out. We have design diversity, but also mutations over time. Design diversity and mutations can perfectly explain what we see today in terms of diversity worldwide in people groups. Okay, and an example of this, as you know, Matt, is blue eyes. Right. And we know this because when it comes to blue eyes, for example, it's only restricted in a specific group of people, which tells us it would have occurred after Babel. Right. When it comes to, because we'll get the question oftentimes, right, Matt, how can we tell the difference between a created allele or an allele through mutation? How can we tell the difference between mutation and created heterozygosity? Well, if it's rare, if it's disease causing, and it's geographically specific, right? Because we see geographically specific Y chromosomes, which is testimony to the Tower of Babel dispersal, because you have people groups that spread out, go to different parts of the globes, and they independently accumulate new mutations. And so that's where you get geographically specific Y chromosomes, for example, or that's where you get blue eyes. Okay, now there is an exception to the rule when it comes to alleles. And this is Dan Stern Cardinale's argument here. As you heard him, Dan is pointing to situations where there's not just a handful of variants, right? But there are hundreds of alleles, up to 1,000. That was what he said. Okay, the human immune system is actually one example of this. The human immune system has a large number of variants. And when you consider, though, the fact that mutation rates are way higher than ever expected in the mitochondrial DNA, the Y chromosome, the nuclear DNA, the Y chromosome is nuclear DNA, but it's non-recombining and it's also uniparentally inherited. Okay, let's make that clear. But we have certain situations, again, where we have hundreds of alleles and not just two alleles, right? A or C, G or T. So how do we explain this? Well, again, we have fast mutation rates, okay? But when you consider the fact that there are 7 billion people on the planet, the mutation rate is very high. Recombination rates differ among people groups, which means recombination rates would have been faster in the past, more effective. We have gene conversion, which also plays an important role. It's not difficult at all to explain worldwide diversity. Just build a family tree, okay? Take Adam at creation, and you'll notice all of the many branches that are created through mutations over time. Okay. That means, Matt, you have plenty of opportunity. You have plenty of time and opportunity for mutations to arise in what? Different lineages and different spots. We also have many genes that are highly mutable, designed to mutate. Because remember, mutations are not as random as evolutionists have once assumed. We also know that the genome is much more functional than the evolutionists want. They need a genome of junk, essentially, no more than 10 to 12%, which means if more of the genome is functional, but we know there's mutational hotspots and mutations are not as random as once assumed, the more functional the genome is, the more non-random mutations are, and the more mutational hotspots there are. Does that make sense? Right? It all goes hand in hand. It's like a package deal. If the genome is mostly functional, that refutes hierarchies in terms of mutational discrepancies. That helps explain the fact that there's certain areas within the genome, for example, the immune system, okay, that are designed to mutate. They're more mutable. Okay, these genes are highly mutable, and therefore in those genes we're going to have a lot of what? Variation that Dan is saying we can't explain in just a few thousand years. No, we would expect to have a lot of variation in those genes. Okay, and again, take Adam, build a family tree, you see all the branches, which means you have a lot of time to get a mutation over here, a mutation over here, a mutation over here, and therefore more variation over time. And I would say a lot of these genes are hypermutable for the benefit of biological organism, right? So some of these genes, like immune system genes, maybe it's beneficial to have more variation in those classes of genes, especially if genes or mutations are not as random as once assumed. And we also understand, here's the last thing I'll say, Matt, and then we're just going to hand it over to you. Hypermutation. It's a reality. We oftentimes point out the fact that a lot of isolated people groups, like let's say you have Neanderthals that were founded by a biblical patriarch in his old age. So right off the bat, bam, Neanderthals are slammed with a whole bunch of new mutations. Plus, they're closer to the flood, right? So they'd be different. They'd already start off with different sets of biodiversity. And then, you know, they migrate to a less than ideal environment and they become hypermutated. And before they're reduced and therefore become inbred, maybe they were hypermutating, became inbred, which means you have levels of heterozygosity decreasing and levels of homozygosity increasing. But at the same time, you have rapid fixation, mutations popping up, recessive mutations popping up, coming to the forefront and being fixed rapidly, which means we're going to expect Neanderthals phylogenetically to be different than modern humans. Okay. But notice this, because you'll get the evolutionists. They'll say, oh, there's no evidence for hypermutation, because we'll point out that a mutation in an important DNA repair enzyme, DNA polymerases. Well, you know what? Mutations in those important DNA repair enzymes means that the mutation rate is going to increase. Or even just depending on where you live. If you live closer to the equator, then environment alone. And here's a paper in 2022. Here's a paper, 2022, pedigree-based mutation rates in the mitochondrial DNA, 10-fold higher than phylogenetically derived rates. Now we have a paper here in 2022. Notice this, hypermutated genomes in people groups today. Two families had genetic drivers of germline hypermutation, with fathers carrying damaging genetic variation in DNA repair genes. I mean, we've been saying for years now that mutations in important DNA repair genes will increase the mutation rate, right? And then if you have a small isolated group like Neanderthals that are highly inbred, those mutations can come to the forefront and be fixed, stuck in place rapidly. For 5 of the families, paternal exposure to chemotherapeutic agents before conception was probably a key driver of hypermutation. There's a lot of drivers. There's a lot of factors at play that can drive hypermutation. If you have one people group that are hypermutating and another people group that are not hypermutating, then guess what? That hypermutating lineage is going to diverge more and more from this people group. That's why you can't look at the lines on phylogenetic trees and assume that the longer branch means it's an older population. No. Okay, because you have like the HVR haplogroup in Europe. Okay, you actually have differing size lines in the same amount of time, telling us that you have people picking up more mutations than other people in the same amount of time. So that means you can't then assume, well, the human chimpanzee split was 6 to 10 million years ago, and there's this many DNA differences separating them, and so we have this really slow mutation rate. No, the evolutionary molecular clock is dead. It doesn't work. Notice this, environment can influence mutation rates. When it comes to the Neanderthal, Matt, the environment that we understand the Neanderthals existed in would definitely increase the mutation rate because they were exposed to some really harsh conditions. And they would have been closer to the flood, So the heat and energy produced at the flood, as well as the accelerated nuclear decay, you'd have rocks with more uranium, which is probably also speeding up the mutation rate, okay? And then you've also got the fluctuating magnetic field. There's so many factors at play when it comes to populations like Neanderthals that make them different than modern humans today. Environmental exposures in parents, such as ionizing radiation, can influence the number of mutations transmitted to offspring. Look at this one, icing on the cake. We also found that the overall point mutation rate is significantly, so not just a little, Matt, but significantly higher in Africans than in Europeans. So if we have people groups today that have higher mutation rates than other people groups, then the evolutionists are in error when they want to use arguments pertaining to levels of genetic variation or phylogenetics to refute separate ancestry. They're not considering rates of gene conversion, mutations, and recombination, as well as hotspots and overall genome function. They're not considering these things. Notice this. Oh, it just gets better and better. Our findings imply that defects in DNA repair genes can what? Increase germline mutation rates in addition to their well-established impacts on somatic mutation rates. So you have somatic cell line mutations, like your skin cells that are not being passed on, but they're higher, and therefore there's an increase in germline mutation rates because there's the potential for more being passed on through the reproductive cell lines, okay? And again, we have gene conversion that breaks down linkage disequilibrium. It's a packaged argument. Dan wants to pretend that, oh, well, the African diversity argument, that doesn't matter anymore because he never knew about the PRDM9 gene. So now he has to concede that and say, well, you know, but the creationists, they still don't know how to explain the fact that we have some, we have this exception where we have some alleles in the human population where you can find, you know, hundreds of variants rather than just a few. One way of breaking up these linked regions, so you have these linked regions, right, that the evolutionists say there's not enough time to break up in the young earth creation model. Well, you have recombination, more PRDM9 DNA elements, and gene conversion, which is admitted all throughout the scientific literature that it's not been studied enough. The process of genetic reshuffling that sees segments of paired chromosomes exchanged through crossover events. Notice this. Another process that can have a similar effect in breaking linkage is gene conversion. So you have linkage being broken not just by recombination, but also gene conversion, which essentially sees one version of a gene being converted to another during double-stranded DNA break repair. And I'm going to end it there because I know I've been going on for a while. So, Matt, if there's anything you wanted to add in terms of that response to good old Dan Stern Cardinale, go ahead, brother. And then we're just handing it to you because it's your presentation time.
Yeah, there was a lot I wanted to add. Share my screen for me real quick, if you can. Yeah, the first thing to go over real quick would be ancient genome size. So they looked into the past and they actually found that our ancestors carried 40 million more DNA base pairs than people do today. Now, I want you to think about that in terms of how large that actually is. That's almost the size of the entire Y chromosome. So I want you to picture if you had a car and it had 2 extra tires on it. Now, cars today only have 4. If we were going to look at wear and tear, which car would wear down faster driving around? It would obviously be the car with 4 tires because it has 2 less to withstand damage. So therefore, we have to assume with the larger genome, therefore more damage could accrue in the larger genome that we just don't see today. Just like cars not missing 2 tires that we don't see, they're hard to judge. We can't tell how good they would have done. We can't see how much better and less wear and tear they would have gotten while driving, but we can assume that there was more, right? It's obvious to me that a car with 2 extra tires on it would get a lot more miles before you need to replace the tires because there's more areas where damage can take hold. Then we look at the geographical regions and look at where Neanderthal lived. We know they lived here in this region. Well, guess what? These are the iridium deposits from the KT boundary, which evolution, of course, says is from the impact from a meteor that we say is from volcanism and massive worldwide volcanoes erupting, and it pushed iridium into the atmosphere. Well, where they lived had high amounts of iridium. Guess that what that would have done? That would have compromised their immune system a little bit as well. Higher compromised immune systems would mean more somatic mutations would have built up in their lifetime. More somatic mutations means more what? More change, more adaptation is required. Therefore, you're going to get more germline mutations, like he said earlier. So therefore, the environmental factors also played a huge role. We also know that there was exposed mountains for the first time ever. And what do we know about Neanderthal? They called them caveman. Why did they call them cavemen? Because they chose to live in caves a lot. Why? It's because you don't have to build the shelter. It's already there. What do we know about caves? Well, guess what? They can have heavy metals in them as well, especially uranium and other radioactive elements. That's why we test home today for people that live underground, and they have to have detectors in their homes to make sure that this isn't toxic levels, but they would have not had these things, and therefore they would have been putting themselves in compromising situations by living in these caves. So all of these massive amounts, plus we have to talk about their diets. We know that when they were living in the snow, they were refined to eating mammoth. We know that because we find that's what they hunted and killed, and that's probably their main caloric source, right? Being in the Ice Age and all. Well, what does that mean? It means they had to cook these meats. Cooking meat adds the highest amount of what are called acrylamides and glycation. We burn it, and it causes the acronym for AGE, AGE, advanced glycolytic end products. And this age does what? Well, it ages us. That's why the acronym is there as well. And they cause lots of mutations to build up. So that as well, right? They're walking around and chasing these animals down, hunting and killing them. And then they're living in caves probably. I mean, they're living in a world where the atmosphere is even more toxic. So we can see there's a lot of factors that they're not considering when they think about Neanderthal. They don't have a different perspective, right? And they've already admitted they believe in uniformitarianism. So what we see today must be true in the past. By taking that mindset, you have already proven that you are anti-science because you are not considering an alternative about the past. So therefore, you've already set yourself up for failure. What do we know about the Native Americans when they encountered the Europeans for the first time after a very long place? We know that Native Americans came from China, and Europeans were right close to that region to begin with. So we would assume that they would have similar immune systems when they lived in the same area. Then the Native Americans migrated, the Asians migrated into North America and filled up South America. And then when the Spanish and Europeans came over, they introduced smallpox. And their immune system couldn't handle it because they had already built up an entirely different immune system after that amount of time. And it wasn't acclimated to what their ancestors would have been able to deal with. And it eradicated them. So immune systems change very quickly and very, very fast. So we're taking what we see today and we're extrapolating that it can't be true in the past, when in reality, the past is very, very different. And so to take the uniformitarianism idea is a really, really bad idea. And it comes from a person that literally made it up. And we'll get into that some other time because we're going to have a lot to cover today. I just wanted to throw in my 2 cents on that subject.
Well, and what I'm really liking about tonight is we hit the hour mark, and we've already hit, especially the parts that I wanted to talk about. You made so many good points there, brother, that I wanted to go here real quick. So here's a comment on Dr. Rob Carter, his recent video. And there's a gentleman here named Schneule. Hopefully I'm saying that right. And he's saying he's just not happy with the solution to differences between Neanderthals and modern humans. But Matt, based on everything we've been talking about and demonstrating, hypermutation, right? Radiation, as you've pointed out, especially closer to the flood, the environmental conditions, the inbreeding. I mean, Neanderthals are the most inbred people group that have ever existed. Their runs of homozygosity are massive, where they just have these massive stretches of DNA where it's just identical letters, right? And we've also got patriarchal drive, where you have Neanderthals that are closer to the flood anyway, so they would have started off with different sets of biodiversity to begin with. If they're founded by an early biblical patriarch in his old age, then you'd start off with a whole bunch of new mutations. Bam, first generation, whole bunch of new mutations, which if represented on a phylogenetic tree would look like this population was a lot older than they really are, right? And we've got real-time examples, as I've pointed out, real-time examples of mutations accumulating in important DNA repair enzymes. This is a 2022 paper that tells us that yes, that not only environmental exposures will increase the mutation rate, which we understand the Neanderthals would have been lacking quite a bit, especially in terms of essential vitamins, given their ecoglacial environment that they existed in. And right here, 2 families had genetic drivers of germline hypermutation. And when these DNA repair genes are affected and broken down, more mutations accumulate. And that means that lineage is going to diverge from a lineage that's not hypermutating. But when it comes to, and tell me your thoughts on this one, brother, and then if you want, just to leave no stone unturned, add whatever you'd like to this guy's comment, is you'd have these Neanderthals, before they like the Neanderthals we have today, they are in their end stage. And we did a whole 3-hour show on Neanderthals. I did a whole lecture on it. You joined me. We did some Q&A after. So we touched on this in great detail. I recommend people check it out. But the DNA that we have from Neanderthals that suggests they were 40% less fit than modern humans. They had massive levels of homozygosity. They were highly inbred. That's the end stage Neanderthal. That's the end stage Neanderthal. That's the Neanderthal when he was at his worst condition genetically, and then obviously physically, right? Because we would have genotypic degeneration and phenotypic or morphological degeneration as well. But we also know that a lot of their features were simply due to adaptations given their environment. But nonetheless, if you go to the earlier Neanderthal, they wouldn't have been as inbred, but they might have entered the environment and were therefore affected immediately by hypermutation, right? Especially with those post-flood conditions and the environment, unfortunately, that they migrated to. So you could have hypermutation and then eventually inbreeding and reductions in so you've got so much going on with this population. I mean, you got hypermutation, eventual inbreeding, increased levels of homozygosity, decreased levels of heterozygosity. You know, you have these DNA repair enzymes being destroyed. You've got environmental related degeneration. You've just got so many things at play, not to mention the fact that they already were different because they were closer to the flood. So I don't know. I don't see this as being a problem in the same way that I don't see African genetic diversity as being a problem. And I don't see Dan's argument about the exception to the rule where we have some genes with hundreds of alleles, more variation. There's not an issue here where a lot of these critics want to say there's an issue. So where he says, I'm just not happy with the current solution. No, I mean, the solution is more than good, I think. Matt, what do you think, brother, if you want to wrap it up there on this one?
Yeah, I don't know really what the person would be able to be convinced of. Apparently, he probably just needs to look more into it. You know, the subjects are very short on Carter's channel, right? He'll go live and record while he's walking out in the woods or something, like he just feels it, right? So he just goes out and starts holding his phone up and doing a recording, and he's not going into it like us. I doubt this guy's watched our 3-hour video on the subject. So, you know, yeah, it's probably, you're not going to be convinced in a 5-minute video, especially if you've taken 4 years in college going over the subject of evolution and looking at Neanderthals. If they became your subject, you know, your study subject, you're not going to be convinced in 5 minutes. I'm sorry. Probably nobody would. So
And this one right here, he says, on the other hand, we don't know how much time has passed for the individual lineages, and their differences between each other are actually very high. Again, we see, Matt, what are your thoughts on that? If you want to even reiterate your position on the environment and how radiation, right, even the rocks right after the flood, the heat and energy, the accelerated decay, we have these rocks with more uranium at that point. And you've got to remember, you have people coming into a new world, right, Matt? It's kind of like, we used this analogy before. You eat a very healthy diet. Your body is very alkaline. You have a strong immune system. If you were to just start doing what that guy did in Super Size Me did, and just started eating McDonald's breakfast, lunch, and dinner, you're going to rapidly deteriorate, aren't you, in a month, versus somebody who's maybe just used to that diet. Somebody who's just used to eating fast food, used to eating garbage, not working out, not having a healthy lifestyle, drinking Coke all the time rather than water. That person is just used to feeling bad. It's like their body is almost in a way adapted to that. Where somebody like you, if you were to go to eat McDonald's breakfast, lunch, and dinner for the next 6 months, you're going to rapidly degenerate. Let's be real. Health-wise, energy-wise, so on and so forth. So you have Neanderthals being an immediate post-flood people group where you probably have more longevity genes, a healthier genome overall, more genetic diversity, since this people group's closer to the flood. They're going to rapidly degenerate in these harsh environments. Isn't that right, Matt?
Oh yeah. I mean, yeah, we're a product of our environment. So the more the body has to adapt to something that's harsh, the more it's going to kind of back itself into a corner. Very similar to the Linsky experiment, right? The bacteria were put into harsher environments and under places where we could irradiate them, where we could freeze them, where we could deprive them and change their diets and put them under light and no sleep. We can do all these different things, and yeah, they can adapt to those different things at a cost. So we see that. Why would a human be any different? We would do the exact same thing. We see that they're very adapted to cold. We see morphological features. They lived in small populations. And guess what a small population is going to do? Even if we had the exact same mutation rate as them, even if it was exactly the same, the fact that they lived in groups of smaller than 20 means that they're going to have more mutations reach fixation, which is going to make them look older regardless.
Right.
Case closed.
Case closed. And right here, this is a good question by Schneule. And he looks like he's being honest, and he's just looking for an answer. And we're here to say there's an answer. Are you aware of any evidence for specific mutations in polymerases in Neanderthals which would cause higher mutation rates? Again, we have people groups today that are existing in not the same conditions as Neanderthal. Again, the environments they lived in, the fact that they're the most inbred people group on the planet. Okay, it's not a stretch to say that they had mutations in DNA repair enzymes, because today we know it's a reality. We have people groups today, and I highly recommend reading this study. I read through it in detail, and they make it clear that environmental exposures, which we understand the environmental exposures immediately post-flood, and also in that local world that the Neanderthals existed in, would have been bad enough to the point where they would lead to accelerated genotypic and phenotypic degeneration. Okay, so we have two families had genetic drivers of germline hypermutation. And a lot of this was due to the fact that DNA repair enzymes were hit with harmful and deleterious mutations. So in that circumstance, notice this: these individual lineages, they would not have to be separated and accumulating mutations very long before they'd be different from each other. You got two lineages, right, Matt? They're spreading out from each other. They're diverging. They're both hypermutating, and then they're becoming more and more different than each other. Right. And think about this, Matt. I'd be curious as to your thoughts here. And then this will be, and then I think we touched on this more than sufficiently. You would have the end stage Neanderthal. Let's say they're hypermutating. Okay. Even before they're highly inbred. Here's the thing. The inbreeding reduces levels of heterozygosity, increases levels of homozygosity. Plus, you have created nuclear DNA differences. You have created heterozygosity too. where not every single DNA differences is a result of the mutations. So in the nuclear DNA, in the highly inbred Neanderthal, what's going to be the most noticeable? Well, the inbreeding, right? But when it comes to the DNA compartments like the Y chromosome and the mitochondrial DNA, those compartments, what may be most noticeable is the hypermutation.
The damage.
Does that make sense, Matt?
Yes, the damage is what we see because that's where it accumulates because it doesn't have the recombination to fix itself. So we see the damage that's caused and can't get rid of it. So I figured we're on Neanderthals. Let's rock it out, right?
Hey, the floor is yours, brother. You go ahead, take your time. I'm looking forward to this.
All right, we're just going to jump right into the creation versus evolution view of Neanderthal. What happened when they first came out? Who made these predictions? What happened? Because when we look over time, we see that the creationists said, nah, these are human beings. And then evolutionists said, no, absolutely not. That's the original drawing of Neanderthal. They said they are an ape caveman, primitive, and they had, fur all over their body. They didn't wear clothing. They were the epitome of a missing link. And as the information got out there, the first genome study came out in 1997. And when this came out, they concluded Neanderthals were not our ancestors. Now, at the time, creationist Dr. David D. Witt, who was teaching at the time, said, oh man, this conflicts with my biblical view. I've always believed that they were a descendant from Adam and Eve, therefore human beings. He said, so I therefore predict, his predictions came true, by the way, that when the DNA sequences were not compared, but exactly which DNA-based pairs were different between Neanderthals and modern humans instead of simply the number of differences. Most of the sites where Neanderthal and modern human differed were sites that modern humans differed from each other. This was confirmation that we were looking at genetically similar humans who lived in the not so distant past. So see, he was teaching at a college where they came out with evidence saying that these were not humans. And this was in 1997. So as a creationist, he predicted, no, these are humans. And that view conflicts with the biblical view. I'm going to hold to the biblical view, and then I'm going to test my prediction to find out if this is true. And sure enough, they lined up exactly with what was going on. And he wasn't the only one. Peter Line in 2005 was a predictor also that not only Neanderthal, but all of these skulls over here as well were humans and no different whatsoever. And so these are just things that you guys can read in your own time, just because of being lack of time. I'll blow through this so we don't have 4 hours here. But essentially, these are predictions that were made on Neanderthal, and he did others, of course, as well. This was him on Homo naledi, which we will get into in a little bit. But the original idea was that Neanderthals traditionally were designated Homo sapien Neanderthal Nensis, were not only human, but also, it turns out, more modern than science has previously allowed. You'll notice the wording right there. They didn't allow them to be. They thought they were a subhuman species, right? And Neanderthals were highly intelligent. They were able to adapt to a wide variety of ecological zones and capable of developmental highly functional tools to help them do so. So this was very confusing because this is contrary to what they predicted. Because remember, they're not human beings to evolutionists. And then, of course, we got the DNA, and they said, oh, man, right here, the analysis of the DNA failed to demonstrate any significant differences between modern humans and them. So, again, we keep seeing the close similarity, so much similarity that if evolution was true, right, polar bears and brown bears, which would be much more similar related to one another because they're like cousins to one another. They can still breed and bring forth offspring. But yet Neanderthal is supposed to be a very long ancient ancestor that we couldn't breed with. But here we find the exact opposite. Humans and Neanderthals are less different than polar bears are to brown bears. And then we have 23andMe tests come back, and some people are extremely high in the genetic similarity department with Neanderthal. So then when we start looking at the species concept, well, now you have another problem because evolutionists like to define species as something that cannot breed with another one. But there's two different divisions of people, of course, but we say, hey, look at this. We can breed with them. Therefore, they must be the same species, making them humans, because humans don't have other species alive right now. So therefore, if we have to assume they were exactly the same as us, they were just adapted to cold. That's what their visual look. That's where we come up with this idea of like, man, their bones are thicker. Why is that? It's because they were adapted to their environment, and their environment was very harsh and very cold. That's why the back of their brain is actually quite extended, because they had better vision than us, because they needed to. Because when you live in snowstorms and you're living around dire wolves and woolly rhinoceroses and saber-toothed cats, guess what? You're going to need some better vision if you want to stay alive. And we know now that they didn't live in populations of more than 20 individuals. Some say 10 to 15. This is a very small amount of people. And a very tiny amount of people, matter of fact, so small that we read that inbreeding would kill them within 10,000 years if they lived in these populations, which they say that they lived in. So you can see the horrendous problem that evolution is having now with these things, because we know they died from inbreeding, and multiple studies have already confirmed this. They had a high mutational burden. When populations are smaller, selection isn't as strong, so therefore they're accumulating more mutations. So on average, Neanderthals would have had more bad mutations in their genome. Oh, look at that. Exactly what we predicted. So what about their visual look? Remember, when they get reconstructed, they have, unique features, larger noses, kind of receding chin, their lips. Well, guess what? These are phenotypic changes, and they're related to a gene. They're no different. So when we line these things up, we go, wow, they look so different. How can they be human when they look so different? Well, they're not all that different from even people alive today. And their children even were not that much different at all. Matter of fact, they didn't even have the brow ridge yet. Here's another one right next to each other. The skull is larger. Yes, obviously, they were living in harder conditions. But overall, besides the size, not too different. Here's a teenager, right? Getting up there in teens, still no brow ridge. Very unique. So then they say, well, the lack of chin is something that's strange. Maybe it's an ancestral trait, or it's more ancient, right? Not necessarily. We say it comes from inbreeding. And this dental record study that I found earlier going into Australia actually found modern day Australians with the same thing. So if you cross it with Neanderthal skull, it matches absolutely perfect. So, and then there is the broken skull, broken hill skull that was found with a Neanderthal skull that was actually shot in the head. So very unique. This person lived who knows how long ago, but apparently they had muskets. So we use different criteria when we are looking for a human in the fossil record. And our criteria tries to identify human beings, and we do this from burial. We find instruments that they made, toys. We found things that they made that were the first movies. These are little tiny pennants that they would spin to make it look like it was running. And this is so small that we actually, they zoomed in to see how small some of the details were, and we can't see them with the naked eye. So completely incredible. They had the first shopping center where they traded goods with one another. So they were clearly able to talk to one another. Why in the world would you be selling something to somebody when you literally can't even talk to them? It makes no sense. In 2020, they found some string and that they made. So their mind is blown. Hey, they weren't stupid, right? We're still on that kind of mindset, right? Shocked every time they find something. Wow, these people, these half ape men weren't idiots. It's weird. So again, we go back to they could not have lived over 10,000 years in the populations with the fast mutation rates that we have. This one's a little too long to go over right now, but here's why after just 10 to 20 generations, they got so diverse, because they lived so long ago that their genetics isn't in us so much today, because it got weeded out so quickly in the original first generations that it reached a saturation point. It reached equilibrium, and then later we come along today and we go, oh, look how distant they are in the past. Well, no, that happens relatively fast, and they did live in the past, so we should expect differences, especially if they were hypermutating. But as it turns out, guess what? They had modern speech just like people today. So they actually found out that they could talk. Here's the geographical region that they lived in. Not a very good time. Actually, only down here were they able to actually find and harvest food and not live off mammoth. Their extinction point was somewhere around here to the north. And that was pretty much it. So their original drawing was this. That is what they assumed. And then we looked at this, their failed predictions all the way going through time. So remember, their first original drawing in 1909, hairy ape man. Then they go, ooh, they only had rickets. So instead of bending their back, they stood them up more. But they still left them in full body fur. Thought they were idiots, couldn't talk, no clothing. Then pretty soon they're like, oh, we found some genes inside of them that actually shows that they had, white skin, lighter color hair. They could probably make weapons and tools, so they made them a little more human. And then pretty soon, there they are, just like us. So I made this one because this is so simple right here. When we look at all the predictions that they made that have completely failed through time, and look at all these failed predictions that they made, that they didn't live with other hominids. Well, guess what? They interbred with Denisovan, Homo erectus, and modern humans. That's case closed. They couldn't speak. They grunted and made sounds. That's completely wrong. They spoke to one another now. They found both the genes, the FOXP2 gene, which were the copies that are used for vocalization. Neanderthal had the exact same ones humans have. The hyoid bone, as you can see up here, for speech. They did not have the same cognitive abilities, and now we know that they actually have the exact same as us, maybe not more. They lived in caves. They couldn't build shelters. That's wrong. We found that they actually build these shelter out of mammoth tusks, and they build them out of skins of animals that they found. They said they're inferior to modern humans. Now that they know that's wrong, they actually found their way stronger than modern humans. So there went that idea. Hunched over. Nope, they weren't hunched at all. They buried their dead. They said they never buried their dead. They said they did not make tools originally. Then they found they made tools. They said their body was covered in fur. That was completely wrong. They couldn't talk. They had no long hair. They had no clothing, no games, no music, no boats. They couldn't have failed more miserably than with Neanderthal. It's a 100% perfect young Earth creation prediction, and evolution failed miserably with Neanderthals down the line, decade after decade after decade. So though they failed on every missing link, Neanderthals is like the royal failure because it goes back to Darwin, right? So it's been around for a really long time. Darwin was smart, though. He looked at it, and you know what he said? He said, that skull looks very large and capacious. And that was it. He set it down and said, I'm not going to say anything about that. Smart man, because he knew that was not what we expected to see as far as the progression of a smaller ape, primitive human being going up to modern day man. It was the exact opposite trajectory. So good times on that one. So if you wanted to say anything about that, I'm going to move on and let you have the floor for a minute.
You're doing a fantastic job, brother. No, I don't want to ruin the pace. You keep her going. Great job. Great information. I feel bad for the evolutionists on this one. All they're going to be able to do, brother, is dodge, duck, dip, dive, and dodge. It's what they do best, right?
Yeah, exactly. I'll jump now down something. It's just to keep this in flow with a very similar type of thing. Okay, now this is going to take us into baraminology because we do have predictions on this, and this is we're looking at the difference between evolutionary systematics, which is phylogenetics, cladistics, and then we have the baraminology and taxonomy side of everything, right? So we have the versions of, are we grouping humans all together, or are we finding an evolutionary tree where one is evolving into the next and branching out into modern day human beings? So what we have then is statistical baraminology, which we take these different methods, which are baraminitic distances, and we look at multidimensional scaling, and we try to find differences between something to find how much relation there is between something and similar to something. So when we look at these distant character traits of each species that are trying to be identified, this information is then entered into a statistical program that compares the similarity or dissimilarity among the species. The findings can be plotted into three-dimensional graphs. Okay, so this man came along, Frank Lewis Marsh, and he said, we should look at hybridization and breeding, because when we look at the diversity of animals in nature, we can also get a broader grasp of the diversity by looking at hybridization and breeding. And he was smart, and this is a great thing that we could have done, because the goal of this is to look for something called a holobaramin. It's where all the created kinds fit, so we can identify the R and Raws, as you know, the phylogeny challenge, because that's what he's always talking about. Name something that God created. That's the phylogeny challenge. Well, this version of looking into the fossil record is the creationist version of the predictive power of trying to find that created kind without having the ability to look at genetics or soft material. Because as you know, looking into the fossil record at a missing link common ancestor, we have a lot of trouble trying to identify certain things because we have a lot of disarticulated or broken bones. So we have to infer a lot. So this is where baraminology comes in, and the goal is this hollow baramin. And we do draw the line in ancestry, family for the most part, and sometimes up to order. But we do have a line where things are broken off. Evolutionists have no line. They just keep going all the way back. That's why they'll say all the time, oh, are you a eukaryote? Therefore, in their mind, you're related to yeast because they don't have any borders. They have no boundaries. So we want to get a successive approximation of where these lines are drawn. And we want to look at the diversity and say, is this chart here true? Like, how many of these things are related to one another? Can we look and make predictions off of this? And guess what? Baraminology does, and it makes predictions on these created kinds. And this is what's good. So this does make testable predictions, which is again the gold standard. So no matter how much you might dislike this type of science, either side, doesn't really matter because it is predictable and testable, and that's what matters most. So when we're looking at diversity, let's say we take a cat. We go, well, how much diversity is in the cat kind? That one on the bottom is a little tiny house cat, and on the top one above it is a big cat, a lion, a tiger. Well, not much. The bones are almost identical. The amount of everything that they have is identical. You take the skulls and you line them up with one another. Basically, the only real difference is size. You get a little bit of morphology difference. Some size, little nose difference. A little wider in certain areas and narrower. So there's not a lot of diversity in cats. So we had to assume that all cats are related. And therefore, we got to track it back to the most recent common ancestor. Now, that gets a little bit more unique when we're looking at human beings, right? Because there are humans and there's a lot of diversity going on. And so we have to look now, what is the limits of this barrier when we look at humans? Because we see some that have a little bit of receded chin, but we notice something consistent. They all have noses, right? They all have foreheads. So we all have flat teeth. We don't have extending canines. So we notice that there are features, again, that are very similar. And when we notice these similarities, it's being charted into this baramiological thing. And therefore, when we look at something like this, we go, what is this? Can we spot the one that's out of place by looking at this? And just briefly scanning this after what we just went over, we can identify which one would be a primate. And we can do that simply by looking at that physical features that we have in this chart by going, yes, it's there right in the middle. And we can see that there's no nose bone. There's the really distended face with canines. And it's been enlarged to trick you guys, of course, because if I made it the size of a primate, it would be much smaller. So being enlarged a little bit kind of fools people. But there you go. There is a primate mixed in that's easily identifiable. And there's a lot of diversity in human beings, as you can see, right? There's a lot, but the diversity can be accounted for and plotted. So when we look in certain places, for example, this one place over in Europe, right above Turkey, we find all of these skulls in the exact same region. And there's a lot of diversity in these skulls, and they were all living in the same place at the same time. So when we see a lot of diversity, it can be plotted. We are now able to say, okay, all of these clearly are human because they're living together and they're communicating with one another, reproducing with one another. So there we go. We have a lot of diversity, but now how can we split that diversity up and what predictions can be made? Baraminology came along and said, we're going to make some predictions early on, even though we don't have the postcranial data yet from Todd Wood and Peter. And they came out and said that Homo habilis and Sediba are going to be predicted to end up being human beings, and they will be plotted with other humans. And then these are the non-human types over here on this side. And you can see Sahelanthropus sinensis was placed over here before the data was in, again by Todd Wood. And that actually ended up being true. Evolutionists lined these up and said Sahelanthropus sinensis is actually the first link of the chain leading to human beings. So it was the most important link of the chain. And if you go even today, I made this morning, Sahelanthropus sinensis is one of the oldest known species of the human family. This is on Smithsonian's very website. And so that's still there today. And what do we know from the new evidence? Well, guess what? It was not human after all. That's right. They went back to the site and they discovered that the new evidence from finding the bones around it showed that it was not an ancestor to their earliest human ancestors at all, and doesn't even belong in the family tree at all. So again, evolution completely failed, even though they still teach it, and they still it's still going to be on their website for probably who knows how long. And it was a prediction that was made by young Earth creationists that we got right. And there's another really good one here that you guys might remember, named Ida, a very popular one. Evolutionists pushed this like crazy. They pushed it so much that actually they put it on Google for a while. It was the 2 O's in Google, and Ida was pushed as the major missing link that was the root ancestor of human beings. And then they came out later and said it was nothing whatsoever to do with the origins of higher primates. So by 2010, it was X'd out, and then they erased it from the history books. They brushed it under the rug as fast as they could, and then hailed it. It was hailed as a missing link, just incorrectly. We were a little bit wrong about that. It's no big deal. So when you see these phylogenetic charts with Richard Dawkins here pointing at these missing links, humans right next to these chimpanzees, these charts are made with so much assumption. It's absolutely hilarious. And the predictive power, even of these barometrical charts being done by young Earth creationists, are still better than the evolutionary charts because they don't have any good future testable prediction power coming from their charts. So I find that pretty hilarious myself, that they have their own system that's been out for a very long time, and they completely fail on all their predictive power. And here's barometrology, fairly new. And it's only being done by a handful of people, very small group, different groups of people, and it's still more accurate. So I do like that they're making these testable predictions. So we will hold our breath and see what happens with these new future testable predictions on Habilis and Sediba, because unfortunately right now we're looking at just one or two specimens of Sediba, one horribly disarticulated and broken up, and Habilis is kind of like a grab bag mix of lots of different things, we think. So time will tell when we find more, everyone. So that'll do it on that segment, and we will move on to grass. Now, scripture is pretty clear that evolution stated no grass, that was a newer, more recently evolved thing. And it evolved after dinosaurs, much later, about 10 million years later, actually. But Genesis tells us, wait a minute, grass was before dinosaurs. So what's going on here? What are we going to find? Were dinosaurs walking around on grass? Were they eating this? Because that's what we would expect to find if young Earth creation is true. But if evolution is true, then we won't be able to find any grass anywhere around dinosaurs, because when they looked in the fossil record, they didn't find any grass. So we were looking fairly good in trouble, right? And that was until fossilized dinosaur dung was discovered on the Cooper lights, right? And they started investigating what did dinosaurs actually eat. And sure enough, dinosaur droppings were full of grain salt of grass. So lo and behold, from the National Geographic, dinosaurs ate grass, 2005. Old textbooks were wrong. They said, look at this. One of the most common mistakes in the prehistoric books is not wrong after all. The dinosaurs did eat grass. So remember, the textbooks for little kids show dinosaurs walking on grass, but it was just hypothetical, right? They were making fun of the drawings, basically. So, the grass shouldn't have been there, they were saying. But textbooks have long taught that grasses did not become common until long after the dinosaurs' end of the Cretaceous period, 65 million years ago. Depicting dinosaurs munching on grass was considered by experts to be foolish, and showing prehistoric humans hunting dinosaurs with spears. Well, guess what? They were wrong. And guess what? Now we know most of the carnivorous dinosaurs that we actually thought were carnivores were actually vegetarians. When we go back and we investigate what they did, after studying 90 different theropod species of dinosaurs, they concluded that vegetarianism is widespread, contrary to the previous thought, and hypercarnivory was relatively rare and potentially a secondary derived, meaning it probably arose later out of need, out of necessity, right? Think about deer. Deer are notorious herbivores. They only eat grass, right? But they've actually been seen eating other animals that are dead. They'll resort to carnivory, and they do it because they'll starve. They're getting hungry. Things can do that, even if they're herbivores. Look at this. Predation did not come from evolution. No physical evolution was required to change herbivores to predator. It was merely a change in behavior. So very interesting, right? Behavior change can spur in. All of a sudden, the body starts producing more hydrochloric acid. The teeth start to get sharper. You're doing these are phenotypic changes that are set into the genome. As far as we know, that is what we are always talking about. This is genetic information built in. And these changes are rapid. We're going to get into more of the rapid adaptation in the Genesis genetics thing that I'm going to give later, and show you how fast phenotypic changes like that actually can occur, and how quickly you can lose your teeth or gain teeth. Very unique. We're going to go over that. So that'll be a fun one. The next one, sorry, these you can tell when I make a picture, it's not very good. But evolution said that the Grand Canyon was formed slowly over billions of years from erosion of a river going through it. Young Earth creation, of course, we predicted that Noah's flood did this. Obviously, that is something that we've been saying for a very long time. Walt Brown has it. And no matter actually what theory you have, considering young Earth creation, when it comes to a flood model, we always talk about the Grand Canyon. So Grand Canyon is down the line pretty much with every flood model that I know of. So they state that over millions of years, the Colorado River has carved out the Grand Canyon. That's in 1992. That's what they've been teaching. That's what they believed. That's what they said. And then guess what? Here is where is the missing rock to this Grand Canyon? This is something that they've even been asking, right? So now they're at the peak. They found at the Grand Canyon, at least these rock layers were lost during tectonic upheaval caused by the great breaking up of a supercontinent. So they have to say that that happened a long time ago, because the last time there was a supercontinent in the evolution theory was a long time ago. So that's where those magical rocks went that carved through this canyon. Because if you actually go to the delta, what do you see? If this is where the river comes out, do you see trillions of metric tons of rock anywhere? Where is it? There's none. Because it's not there. It was washed away in the flood. They had to invoke that. No, it was broken up and lost when it was still a supercontinent. But then we have a problem. When we go to those layers, we find no bioturbation, which means that the organisms that lived in those layers were bouncing up and down. These worms and bugs that lived in the soil, that would have lived in this geological ecosystem for millions of years, there's none there in these rock layers. Instead, look at this. We get down there, there's lack of burrowing. When we look at these two different layers right here, where is it? There's just lines. We don't find any living organisms around there, right? But what do we see? We find trackways, but no organisms. Why are there no organisms there? That doesn't make any sense. We find the trackways for the trilobite, but we don't find the trilobite. But what's it doing there? It's in a layer that's millions of years younger than the one above it, right? But yet you're telling me that this trilobite lived for millions of years? And then when we go even closer, look at that. We find a leaf and going through annual layers, right? That is supposed to be laid down. But wait a minute, this isn't supposed to be there. That would be destroyed. It's a leaf. That's the most delicate thing you could probably put there. What's it doing in between two different layers? That doesn't even make sense. And here was a recent lecture that was just given on Standing For Truth channel. And look at this. These buttes right here are made out of different layers that is just thrown right there. Like he said, it's like God put those there to remind people of Noah's flood, because there's no possible reason that these could be there unless a flood placed those there. You know, we're looking at throughout the Grand Canyon, these shale and large cracks right here that you can see are going through the geological layers. If these were forming slowly over millions of lines, what's there a crack doing there? They can't say that they formed and then the crack formed, because the crack doesn't go through the other layers that are above it or below it. They're running through just these row right here, and there's no shifting going on. But yet, what do we see? We see missing rock layers everywhere in the Grand Canyon, all over the place. This layer is missing 1 billion years. And yet, what do they say about it? It's the finest record of geological history anywhere on Earth. Well, if this is the best history they have anywhere on Earth, and it's missing over 1 billion years in just one layer, that's not a very good sign, is it, guys? Not really. So this was supposed to be challenging your thinking. This was a book made for kids. They said the Grand Canyon shows wide looping, meandering rivers. So how is that? The walls are youthful, right? These walls, why the rapid rate of decay pushing debris from erosion into this river is fast. So how could the walls still be there? That makes no sense. They're so young, right? And then, you know, you can watch a video that I have called The Fossil Footprints that falsify it. But we're going to look here at these dinosaurs stepping through these millions of layers of rock. Like these footprints shouldn't be going through multiple layers of rock, right? We're finding fish, schools of fish swimming through and being trapped. This is a process. It's not time. That's all we're saying. And then here we have more rock debris. Look at this. This mountain is right here destroying and falling down. This is erosion. And these rocks are already piled up. This is along the banks of the Grand Canyon. And that river is going to take them and rush them downstream. And guess what? That's what we would expect to find. Eventually, if millions of years, there'll be millions of metric tons there. It's not there. And the reason it's not there is because if the rivers carved these huge canyons over billions of years, why aren't there millions of Grand Canyons? There should be. There should be a lot of them, and they should be everywhere. The global flood can produce something, though, and it could produce Grand Canyons as well. But the rivers are going to flood in different regions. Matter of fact, there is a gigantic Grand Canyon in Greenland. But now what do they say? The geologists had to rethink that how the Grand Canyon actually grew, and now they said it grew in a spurt. Guess what the young Earth creation model says? We said the mountains formed at the end of the flood fast, and it formed from massive flooding. What they have to do to save themselves? Well, it happened 750 million years ago. So young Earth creation wins yet again. They had to concede to it forming from a flood and that it formed rapidly. It could have never formed slowly because the geological and visible and physical evidence isn't there in any way, shape, or form. It's just missing in all over the place. And considering this is their finest record of geological history, and it's not only missing the geological layers that they need and the time that they need, it's missing the very process that they said made it occur. So it's literally game over when it comes to that. Next, we have a supercontinent versus multiple continents, right? A lot of people believed at the time that the continents were set in and that they were stationary and they did not move. And creation was the first one to predict, nope, the continents were actually probably different in the past, right? We read about a Noah's flood, and that's what we would expect. So Antonio Snyder Pellegrini was the first one who actually looked at the continents and said, hey, if you puzzle them together, it seems like they're joined into one single supercontinent. And if you go back to the earliest books, I actually found it. And it states right here in 1856, by the early 1900s, a number of European geologists accepted the idea of continental drift. So we actually find that this was the first person to predict a supercontinent, and he was a young Earth creationist. And he wrote it in French, of course, the original book, but he stated that the Earth looked like it was due to biblical events. And it was the first time that the continents that surrounded the Atlantic Ocean were brought together ever. And here's the original image that you guys can see in 1856. And it wasn't until years, decades later, that they finally confirmed, looking over at the evidence, saying, look at this. If we puzzle these continents together, we find the fossils that match each continent before it broke apart. And that's what confirmed Pellegrini's, the young Earth creationist prediction of a supercontinent, was actually true. So before modern day plate tectonics, the scientific community firmly believed that the continents and oceans were permanently fixed on the young Earth, or on the Earth's surface. That was old. And then Pellegrini noticed in Genesis 1 that God gathered the waters all together in one place, like a jigsaw puzzle on one supercontinent that must have broken apart at some point, right? Probably during Noah's flood. So there we have it yet again, another young Earth creationist using scripture, making a prediction. And then there we have it. And then we have the continental movement versus continental fixation. So now what do we have? We have the slow uniformitarianism prediction of the slow spread of 3 to 6 inches per year. It's uniformitarianism. But the young Earth creationists came along with catastrophic plate tectonics, and we said no. So Tim Clary, in his book, Carved in Stone, Geological Evidence of a Worldwide Flood, he predicted that the seafloor spreading would show signs of slowing down in rock layers that we young Earth creationists interpreted to having been occurred in the late receding phase of the flood, which correlates to the end of the Tejas megasequence about 4,500 years ago. Predictions were made on what rock layers would show the different rates of movements. In 2020, the results from Brown University, not even a young Earth creationist, the University of California, Santa Barbara, examined the spreading rates of 18 different ocean ridges and confirmed these predictions. The greatest slowing of the spreading rates and subduction rates coincide with the early Pleistocene and the late Tejas megasequence, when most of the world's plates had nearly stopped. This is also when we see that the flood had nearly drained off all of the continents. So when we look at the maps in the late Tejas, we see that this is the flood waters receding off the continents and the plates that would have been around it. And it is exactly what was predicted. These are the ages that correlate right with it. And we can see it on all the different continents that have been tested so far. And again, this is a catastrophic plate tectonics prediction that was made way ahead of time and way up here in the Zuni and Tejas megasequences, where they were predicting this is when the flood started, this is where it will move the fastest, and this is when it'll start to slow down, and this is when it'll stop. And they got everyone right. So powerful predictive power. So is the seafloor always changing? It's an ever-renewing system of creation and destruction that shapes it. Right now, the new research in geophysical research letters suggests that the process is slowing down. So even the secular community now are noticing that there's a slowing process. So how did they discover this? Man, that picture's horrible. They took boats, they did sonar scanning of the ocean floor, and they ran it over, and they followed the tracks, and they followed the mid-Atlantic ridge, and they said, "Oh my gosh, this is evidence that there was a different speed of these movements." And the young Earth creationists were like, "Exactly, it's what we've been saying." So made a video on it not too long ago. It's on both of our channels. It's called "The New Predictions of the Flood Confirmed." It's a short 5-minute video. And if you guys want to read more of it, here is the answers in Genesis written by Dr. Andrew Snelling in 2015 on more evidence for rapid genomic or geomagnetic reversals. Something Donnie mentioned earlier. So again, we have young Earth creationists on the flood, evolution devastated yet again. We shall move on. Next one. That's right, everybody. Comets brought the oceans from space and put them into our oceans. What do you think of that? Make sense? That's what evolution predicted. Earth was formed by meteors, and our oceans
Another evolutionary fairy tale, eh, brother?
That's right, man. They just throw them out one after the other. They don't even worry if they're going to fail as a prediction. Do you know why? They'll just say, oh, well, we learned more.
Well, and that's why I'll just add this, because I find it hilarious when we debate these guys or review their videos or moderate their debates. They'll say the evolution model makes so many testable predictions, and look at all these ones that have been confirmed. But yet what they don't talk about, Matt, is the fact that the ones that they say are confirmed were actually not confirmed. They actually failed, like Tiktaalik, right?
Yeah.
Where we find tetrapod foot tracks 20 million years, according to their model and timescale, before predating Tiktaalik, tetrapod foot tracks. So that doesn't work. The prediction with the chromosome 2 fusion, as you like to point out, there was a problem. Humans have 46 chromosomes, and the great apes, which the evolutionists will just say, we're a human ape, but chimpanzees, for example, have 48. So to them, that's an issue. So they needed the fusion.
Yeah.
So they had to retrofit it. Well, maybe there was a fusion, and therefore what they had to do is look in the genome and find anything that to them looks like a discrepancy, right? So where they found what they thought was the chromosome 2 fusion and propped it up like it was evidence for a, past fusion, turns out it's not the case. That so-called fusion site actually represents an active promoter for a functional gene, an essential gene that overlaps it. So it's a promoter for that gene. It's a promoter for the DDX11L2 gene. You don't get highly essential genes by slamming together 2 chromosomes, okay? And then the so-called, remnant telomeric repeats actually turn out to be functional DNA elements that are involved in gene expression. And it turns out that there's a lack of ape-specific satellite DNA around human chromosomes that should be there, essentially, if there was a fusion event in the past. So my point is, brother, is even what they say is a confirmed prediction, when you actually look into it, it's not. It fails. And the ones that they do get right, it is a lucky guess, because as you're pointing out, they make hundreds and hundreds of predictions. They're just throwing things at the wall and they're just seeing what sticks. And it turns out a couple, not even impressive predictions may or may not stick. And even if you look into those, they're still a fail. But it's the creationists, as you're pointing out, like the cold slabs, prediction after prediction after prediction in the world of genetics. We're the ones that are meeting the gold standard of science. We're the ones that on paper right now, we're actually making predictions in the world of genetics, and genetics is the best way to answer this question of ancestry. DNA function related predictions. I have DNA function related predictions in my endogenous retrovirus handbook that I highly recommend. Anyone in the chat who hasn't picked it up, I've got it in the description box of this video, as well as all our other books where we've made other predictions on DNA level hierarchies and the multifunctional nature of a lot of these genetic markers. So, that's an important point I just wanted to reiterate, brother. A couple lucky guesses is not impressive, evolutionists. And the ones that you love to hold up in every single debate as a confirmed prediction, when you actually look into them, they've failed. And they've got hundreds of just flat out failed predictions where they like to distance themselves from, because egg on the face, right, brother? So anyways, I'm just ranting a little bit, so I'll hand it back to you.
Yeah, man. No, I love when they throw out their prediction, because I know that it's a failed prediction and we got it right before them, every one of them. So bring it on. Throw out your stupid prediction. I already know it's going to be a failure. And so now that I'm compiling this list for everybody, it's over. So yeah, you guys are going to just smash every evolutionist from now on, because they've lost their only power, which was their predictive power that they think that their theory had, especially when it comes down to genetics. But like I said, they predicted that the Earth was formed by meteors, okay? And that's exactly the process of how it grew its mass and why we are on it today. But then there comes a problem. Because when you get into it, what do we see? The book on meteorites itself said the lack of fossil record for true meteorites is actually puzzling. You see, in the fossil record, there's not very many fossil impacts. So if the planet was made from being hit by meteors over millions of years, and every geological rock layer should literally have millions of impact craters, right? Because the very rocks themselves would be from meteors. But that's not what we see. There's not many impact craters at anywhere in any geological layer. Matter of fact, when you get into the layers, where are they? Well, 71 of them. Go ahead. This is, by the way, the biblical dating on the right of over 4,500 years would be 71 impacts, is basically one a year since Noah's flood. We would predict that a lot of them would be actually during Noah's flood, probably from fountains of the great deep breaking forth and throwing them into the air. But this is also favoring the idea that all of these impact craters are actually impact craters, and they're not, which I'm going to get into in a minute. But first, what about that gigantic meteor impact that killed the dinosaurs? Was this really an impact? Because I don't think so. The very thing that they need to be true the most is that one that wiped out the dinosaurs, because that's their bottleneck. And things were actually looking a lot like the modern world in some respects early on. There was water, potentially some stable crust. It's not completely out of the question that there would have been a habitable world and life of some kind. Wait a minute. It's supposed to be a hellish, look at this, a hellish world being bombarded by meteors and no oxygen. How are you going to get life to form with oxygen when it oxidizes everything? You can't. You need no oxygen. You need this type of environment. But what are they saying? Look down here, a stoutly solid, temperate, meteor clear and watery world, and Eden from the beginning. These are secular scientists saying this. And what do we know about a world like this that's coming out of volcanism and lava's creating all these different rock layers? Well, guess what? Granite, when it melts at 1,382 degrees, it becomes rhyolite. It doesn't come back into granite. You can't have granite after it becomes rhyolite. So therefore, mountains would not be granite. If they were ancient, being pushed up slowly through tectonic plate from deep layers, they would be rhyolite, and they're not. How about our oceans? Our oceans were predicted to come from carrying bodies of water from solar things like comets, right? That's where they came from, comets or asteroids, right? Failure. Comets can't deliver the water. They don't match the ocean. They don't match anything. They would have to have the same type of mineral composition. They don't. So the ocean is no longer. How about this one? How about, are they getting saltier? How about the oceans? We have a failure of the predictive power that the Earth was hit by meteorites and then it formed, and then we have a failure that the oceans came from comets or even asteroids, water inside. How about the salt in the oceans? Right? We have Edmund Halley. He said the saltiness of our oceans is increasing steadily. As young Earth creationists, we would have expected this, since it was not that long ago that the world was submerged in global flood, right? So in fact, the prediction was that the first proposed by Isaac Newton, whose colleague, he was a Christian creationist and a member of the Church of England, Sir Edmund Halley. He was famous for the comet that was named after him, Halley's Comet. And basically, what did we find? We looked over and we were like, wait a minute, there's an upper limit to how much salt or the oceans before there's an equilibrium reached. And it's only 62 million years. So how could the oceans be billions of years old? So if you want to read more on those, there's the ocean salty articles from ICR and creation.com. So they've completely failed yet again. Absolutely miserable when it comes to the Earth and the oceans in like every regard. And then it gets even funnier, because how about marsupials? They said that marsupials originated in Australia. Oh, sorry. I saw you full screen. You want to say something?
No, you're good. You're good, brother.
Okay. All right. We have biblical model says the ark landed and the animals got off. They diversified. They filled the world through migration. They said, no, Australia is where the marsupials evolved, and this was an island, so they cannot have gotten anywhere else, and that's where they came from. Then comes the new cave drawings. If that's a dinosaur, I don't know what I'm doing in my life. I need to retire from everything, because that is not a dinosaur. That is a kangaroo. That is a marsupial. And guess what? This marsupial drawings that they're finding are in India. They're not in Australia. And they date these as very old, not being in Australia. So therefore, kangaroos have challenged the evolution theory yet again, finding these ancient drawings throughout India in cave drawings that you can find online yourself and look at. And it's very vivid. They're very easy to see. And they said, interesting, marsupials must have been, they must have gone that way and died. It's like, no, it's reverse. They hopped their way over there. When the land bridge was there, the ocean levels rose and it trapped them. That's why when we look at the diversity of marsupials on maps, they're not confined to Australia. We find them in North America and South America as well. Not what they predicted whatsoever. And then what did we say when you Google it now? Did marsupials evolve in Australia? I'm sorry. They said marsupials absolutely categorically did not originate in Australia now.
And that's why when the evolutionist likes to ask, how did the kangaroos get to their present locations? And the best answer to give them is the same way that they get wherever they go. They hopped. That's how they get everywhere.
Yeah. Exactly. How do animals get where they go? Well, guess what? There's a lot of different ways. The flood waters were receding. They might have been able to float on debris. They could have hopped there. There's also the consideration of where did they land? This is the furthest part away from where Noah's Ark could have been if you place it on Mount Judy. That's the farthest possible location they consider the Ark to be. I've placed the Ark myself over here from the Book of Jubilees, placing it in the highest mountains on Earth. And so that would be the shortest distance. Again, not too far in general when you've got, 1,000, 2,000 years to hop your butt all over the Earth, So I explain the genetic diversity pretty easy. And then guess what? If you go by the fossil record, which is what they do now, they found the oldest marsupial, basically something with a pouch, over here in China. Guess where I placed it? Noah's Ark, right on the Himalayan mountains, which is right next to China. And that's where they would have gotten off. And the Metatheria are marsupials like the kangaroo, which they have now found in China as the oldest living ancestral species. So evolution failed completely again, and we're finding evidence that they did not evolve there. They admit genetically they didn't start there. They found evidence in the fossil record, and they found cave drawings as well. So literally every single thing that you could ask for proves that their failed prediction yet again. Good times. How about language? Humans evolved language from grunting sounds, copying animals, and there's a lot of theories. There's 8 of them that are really the major ones. And then, or did God actually teach Adam language? Which one seems to be the most true? Because there's only 2 beliefs. There's only 2 options here, and it's the belief in divine creation or natural evolution did it. And if we look at the origin of language, we find that the origin of language in Homo species, or human species, has been at the top of scholarly discussion for a lot of centuries. In spite of this, there is no consensus on the ultimate origin of human language. And this was stated by Fromkin and Rodman, human origin language. And then we get into the 8 major concepts. And I have a video on this, of course, you guys have probably seen. The most popular one is the bow wow theory, which is copying the sounds of animals. And we just grunted them into sounds. And, the cat goes meow, so we name the cat meow. The dog goes bark, woof. So we name the dog Wolf. And therefore we have a wolf because the dog went woof. Right? That's what they believe humans got their language from. Unfortunately for them, linguistics have completely destroyed that, because when we go back and we look at human beings, we find by Lindbergh, who looked at feral children most predominantly, looking at one human being in general, which is this girl right near, Jeannie Wiley. They found that human language goes through different acquisitions, and that after puberty, your brain has matured already to the point where it can no longer be plastic enough to learn language. It has to be acquired first. So language input has to be taught. It's not something that can be learned. And remember, we're talking about grammar, okay? We're not talking about sounds. We're not talking about like the word ball or frog. We're talking about grammar. Grammar has to be present for language. Okay. So again, we jump all the way back to this person who's done more study on it than anybody. And over the past 350 years, we find that people have not been able to occur language after the age of puberty. What that number is still up for debate. But we look over here at Jeannie Wiley. She was neglected and raised as a feral child. And she did the same thing. She never acquired language, even though she lived in a home that treated her really good. So there's a 0 through 12-year acquisition period for trying to learn human language. If you do not acquire it in that time window, you cannot learn it. This becomes a horrible problem for evolution, as you can imagine, because this places the limit of age to learn language, to teach your kids 0 to 12, because you can't learn it after that, right? So there are some debate on when that age is. The highest one of all is by Johnson and Newport, and they say it's 15 years old. Again, it goes by puberty. So some girls were reaching puberty at 15 years old, but most of the time it was around 12 or younger. And therefore, the younger obviously makes this even worse for evolution, because by placing the age at 6 or 5, now evolution is completely in trouble, because you're leaving the entire demographic population of the world to learn language at this age. And it just can't be done. And after 350 years of working with feral child and neglected children that never learned language before puberty, they still can't teach them language. So how would it be possible for an adult to learn language, to pass it on, when they can't learn it? It's really that simple. The brain is very unique, though, because when we look at orphan genes, we find in the human brain it's very concentrated, and it's not in the brain of chimpanzees. It's actually in their skin, and the neurons are in different places. We find that only humans have rose neurons in the brain. It's not in primates. So we again say that God did this. He taught Adam. That's what scriptures tells us. And then again, there was another formation of language later at the Tower of Babel. And that is where humans got more languages rapidly. He taught all humans in one day. So we have that explanation, which is why it makes more sense. And we've heard before that, well, if monkeys had the ability to talk, they could. Well, guess what? They do have the ability to do it. They've hooked up electrodes into the vocal cords of monkeys and made them say things. It sounds a little gravelly, but they can make them talk. And so why don't they? They can't, because they're retarded. And they're not for humans. So human language appears to be a unique phenomenon without significant analog in the animal world. Only humans have it. Only humans will ever have it. And they try to say that, oh, they teach, these apes to sign language. No, they don't have grammar. They don't know about tomorrow. They've completely failed when it comes to doing those things. And I find this ironic because it's so true. They said, shortly, the public will be unable to think and reason for themselves. They'll only be able to parrot the information that they've been given on the previous night news. And that is sad and very, very true in the kind of world we live in, because people don't question anything anymore. We're locked in this paradigm of like, oh, well, it's the way that it is. We look at this world and we see creation, they see evolution. Like there's no oxygen in this part of the world, right? And we say, wait a minute, God created the world to be inhabited. That's what scripture tells us. Evolution doesn't care about that. It's just like, well, whatever. No, we from eons of death and decay, life arose, that's just, we got luck of the draw, right? So they said that their atmosphere had no oxygen, and they have to say that. Why? Because oxidation would kill anything. So all of their abiogenesis requires that. And how do we know? Because it just is. That's what we know. Oxidation is a horrible thing. And what do we find? Where do we go here? Well, Dustin Trail analyzed serum in Zychron, which are crystals, to find higher oxidation than previously anticipated. That means suggesting that there's more oxygen in the atmosphere than Miller presumed from the Muller-Urey experiment. Remember, he erased oxygen so he could get his Muller-Urey experiment to prove that life can arise. And then what do we see? Oh, look at that. Life, the world was watery, full of oxygen, and an Eden from the beginning. So again, evolution completely destroyed and creation confirmed. And it's so simple, we look at things from totally different windows when we look through the eyes of a creationist and an evolutionist, because when I believed in evolution, I didn't really question too much. When I was like, okay, the ginkgo biloba tree is 300,000 years old. It's 300,000 years old. It's a really old tree. It must have lived when the dinosaurs were around. You guys can find that because it's actually in my original book on health. So obviously I believed it. I didn't even question it. Then I started to question. I'm like, there's some discrepancies going on here. Should probably look into these a little bit more before I just state things as though they're fact. But we do that a lot and we don't question. And that's not good, because that's what the news and that's what they program us to do. They program us to not think, just accept, because they want a nation of workers, not thinkers. So then we have what we would expect to see from creation versus what we would expect from evolution. We would expect that if evolution was true, we would be able to look around and we would see supernova remnants everywhere, because the universe is literally billions of years old. So we go to NASA. And what does NASA tell us? Well, in the Milky Way and the galaxies similar to the Milky Way, a star explodes every 26 years. So it's very easy to do the math. So therefore, 140-year supernova remnants, there are 250 known SNRs. Oh, wait a minute. Look at that. That's only about 7,000 years worth. What's going on? That doesn't match evolution. Not even close, right? So here we get, at a rate of the supernovas are occurring in galaxies, we only have about 7,000 years worth of these remnants. These are secular. This is NASA stating this. This isn't just like me throwing this together. These supernova remnants should be everywhere, and they're visible. So we can see them if looking into space. They're very large and they're very bright. So for the lack of evidence, evolutionists have to use time. This is their rescue device, right? No matter how much evidence points to it, just add time, they'll get rid of it. So they want us to believe that all these SNRs only leave a trace of their existence for 7,000 years, and then they disappear so much that they cannot be seen anymore. That's what they want you to believe. Okay, think about that. Use basic logic on that one. Okay, they want. By the way, the coincidence lands on the biblical timeline is pretty funny and ironic to me. But the frequencies of these supernova are without a doubt. I mean, they've been adding them up for quite a while, and we can read through the data that it just doesn't match. And they, of course, they have rescue devices. They always do. They're like, well, we don't see them. We'll find more of them later. There's always something, but they're so bad. They're desperation at this point. And it's funny too, because why does everything keep pointing back to the young Earth? It doesn't have to point to the young Earth creationist timeline, but yet everything points right there. How about the angular momentum paradox, right? This isn't very good for them. Planets are tilted to their side, but they shouldn't be tilted, right? They should be flat. Like, why is Saturn tilted on its side so we can see its rings? It should be flat. Why is the Earth tilted on its side? Well, that's the angular momentum problem, right? It represents 97% of the total angular momentum of these things. This angular momentum is a paradox, and it's misappropriated when we compare it to the model of the stellar birth. So another paradox arises. Like, how did they get turned like this? Like, why are they like that? It's like God tilted them on their side. There you go. Now you can see the rings better. Hope you enjoy it. It's amazing. So Dr. Paniza says that the best data we have are exactly what I would have predicted had I got nothing but the first 5 books of Moses. Amazing. Crazy if you think about it, really. So how about the moon? Is it old or is it young? Because here's a concept that we're not supposed to use anymore. The young Earth creationists aren't supposed to use it, but I'm going to use it, and I'm going to tell you why to use it and why it's still a good argument to use. So what happened is they predicted that there would be layers, even several miles deep, of dust on the moon, considering how old it is. If you go back into the text, they said before 1969, there was a great deal of research to determine what the surface of the moon would be like, right? How many feet thick is sand? They needed to know because they had to land the lunar module on there, as you could see the wide base. So they knew they had to come down on this, and they definitely assumed that was a huge debate at the time. How many feet thick is it? Not is it going to be that way? Also, how thick was it? Is it going to be rich, dense and heavy, or is it going to be fine dust? That was another argument. It wasn't predicted ever that it was going to be a very fine thing of dust and debris. No, they said, no, it's going to be thick. Now, is it going to be soft or hard? We don't really know. So they prepared, and they prepared by putting huge bases on the lunar module so they could sink into it. The wider the base, it's like skis, longer the ski is, the better. You're not going to sink in. The easier it becomes. So the reason I use this is because predictions, right? So even though they say now that solar winds and meteor impacts hitting the moon could blow the debris and the sand dust away, it still counts as a failed prediction on their side. Why? Because they predicted that it was going to be thick based on deep time evolution. So even if it's true, 100% true, that solar winds can blow all that dust away, it still doesn't matter because it's a failed prediction. And the evidence still points time and time again to us, young Earth creation predictions. We predicted that there would be a little bit of dust, and there was. Now here comes my 2 cents. Look at this. We're going to zoom in at the moon right now, and we're going to go all the way into when the lunar module actually landed, and they left the bottom of the pad there. You can see the lunar module right here, but look at this. Yeah, you can see the lunar module, bam, right here on the center middle. They left it there. Now, we see this unique track over here on the right-hand side. Guess what that is? Those are foot tracks from the people walking on the moon that are still there. They walked all the way over there. This was 50 years ago, by the way. They went back, and guess what? The tracks are exactly the same. So my logical question would be, wait a minute. If there is solar winds blowing sand off the moon, and that's why it's not there, how come after 50 years, the footprints are no different from the first day they stepped there 50 years ago? So I think the argument still holds philosophically, logically, scientifically, that their rescue device is wrong and the moon is young based on there being a lack of dust and solar winds not being accounting for blowing all that sand off the moon, because if it did, it would have been like a sand dune and you would have been able to see no tracks left because wind would have blown it, especially from 50 years ago. So get out of here with that nonsense. That makes no sense logically at all. The next one. How about cosmic inflation or cosmic stability? Again, young Earth creation wins, because guess what? The universe had a beginning in the biblical creation, as where the biblical start of the universe for the other one was that it was no start at all. That's right. It was infinite. It was a static, eternal universe that lasted forever and will be eternal. And it was by Thomas Digges in 1590, probably. So this is the cosmological model in which the universe is both spatially and temporally infinite. And then we get down to the young Earth creationist, or I should say Catholic priest at the time. Who knows if he was young Earth creationist back then? Now they believe in evolution, but who knows back then? But guess what? A creationist predicted inflation and that the universe was expanding. And guess what? The Bible states it too. There was a beginning in the beginning, and God stretched out the heavens. Over 17 times it starts out with that. So we read two different things. One, a starting point, and two, a process of expansion. So using that, he was able to predict that there was an expansion and a beginning. Guess what? He was right. So what do we have? We have a flat, or we have a round expansion. Well, guess what? Light travel has a problem. It's called the horizon problem. And you can't have a flat universe you can, with a horizon problem, because that is where it comes from. You can only get rid of the horizon problem by having an expanding universe. And that is what we have. So again, young Earth creation prediction for the win yet again. Then we have the recession of the moon, right? We're losing 2 inches a year. So the evolutionists are like, okay, no big deal with that. It probably comes back in, it's gravitationally controlled. Well, we keep losing it, guys. So, I'm sure you've got something you can invoke. But if we contract that moon back 1.4 billion years, it's in contact with Earth. And yes, I know that you have a hypothetical model that predicts that the moon came from the Earth and that it broke off and that it got trapped in its orbit. And that's why we have the moon today. But again, what we have the math and we have those numbers, and that's not when the moon supposedly came from the Earth, because it would have destroyed all life. And you can't have a moon slowly moving away at 2 inches, because life couldn't live. You can't have life with the magnetism and gravity and all the other, and the ocean tides and everything else that the moon controls on the Earth, with a moon that close to the Earth. And it really is a problem, because we find that even Stephen Hawking and other people say that it's remarkable how finely tuned and adjusted everything is. And here's Richard Dawkins and Hitchens admitting that, not just Stephen Hawking, but the two biggest critics of all of it, literally admitting the exact same thing.
I've read The Language of God, and indeed I reread it today. I read it first when it came out. when you come on later to the origin of the physical constants, things like the speed of light, gravitational constant, and strong and weak force and things, physicists agree that if you change any of those constants by even a very, very small amount, then we don't come into existence. The universe doesn't come into existence. They have to be like that in order for galaxies to form, for stars to form, for chemistry to form, actually, and then for the prerequisite for life to evolve needs that as well. So that's the nearest approach to a good argument.
So it seems like the house of cards that was built by the new atheist is starting to fall. Not only does Richard Dawkins admit that the fine-tuning of the universe may be a very good argument for God, but also the late Christopher Hitchens did as well. Let's take a look.
Quite certainly, we all asked, well, which is the best argument you've yet come up against from the other side? And I think every one of us picks the fine-tuning one as the most intriguing.
The Goldilocks.
Yeah. Okay. Fine-tuning that 1 degree, one hair different, but nothing. So.
One hair different, and you've got nothing. There's nothing so they admit that fine-tuning is obvious and clear, and it's the best argument that they've got. They have no answer to. And it's we've got evidence all over the place. We're just going over some of them today because these are the predictive powers that we keep mentioning, right? So here's one on comets, right? The Oort cloud is one that they predict came from, right? Comets are made of ice. Every time they pass near a sun, they lose mass. A comet could orbit for a maximum of 100,000 years before it runs completely out of material. So where do they come from? How are they? Where are they? Here's the rescue device that they use. They said the secular astronomers have proposed that there's a vast reservoir of potential comets basically hiding. They're orbiting beyond a visible solar system called an Oort cloud. This cloud is said to supply new comets as old ones are destroyed. Has anyone ever seen this? Absolutely not. So what do we have? We have this madness that I got right here. So that to deal with this paradox right here, evolutionists invented this hypothetical Oort cloud, but essentially it's another failed prediction. So there's zero observational evidence from this. Astronomers have found many objects beyond the orbit of Neptune, where the Kepler belt is supposed to be, but there isn't any clear signs that this is actually the Kepler belt, because there are different objects and different compositions than comets. So it might not even be it. So the only place that they think it is doesn't actually match what they need it to match. So secular scientists claim that comets are leftover fragments from the formation of the solar system 4.6 billion years ago. But how can that possibly be with comets? Because they just don't last that long. And why aren't there thousands of comets still visible? right? There's only a few. So scientists were shocked to discover that this dumbbell-shaped comet called Halley's Comet still it contains a large amount of carbon dioxide, and this CO2 was outgassing from the comet's nucleus. This is only possible if the comet is young, since CO2 is only ever able to escape from a comet's nucleus into outer space, right? You can't put it back in. It can only get out, right? So they wrote in a news report that said large amounts of carbon dioxide was inexplicable, right? They don't even know what to say about it. So to try and resolve this paradox, evolutionists had to resort to invoking the idea that CO2 must be flowing back inside somehow. They gave no ability to say how, why, nothing. They just said it must happen. So unbelievable yet again. So the Oort cloud is just made up of the icy pieces. Sometimes those debris are jolted out of the cloud and towards the sun, becoming comets. This is what they said. So NASA claimed in 1995 that these pictures showed hundreds or to thousands of stars forming, which was at the base of the speculative EGG star formation theory. It has recently been tested independently with 2 infrared detectors that can see inside these dusty pillars. What did they find? Few stars were actually there. And 85% of the pillars had too little dust and gas to support star formation. The new findings also highlight how much astronomers still have to learn about star formation. Oh no, it's not a star nursery. The major thing they've been talking about and showing on the news for decades and telling everybody about, and all these people still believe to this day, and will believe for a long time, because when these things are wrong, they don't just like tell the public, they just sweep it under the rug, and all of a sudden you can't find the pictures anymore, and they don't talk about it anymore. Like Ida, right? They just, it's just gone. Don't bring that up again. Unbelievable, right? Just the list is so long. I covered like half these things, so I'll wrap it up. Let's I'll just go through a couple things that I thought were real quick. Here's one. Creation. Man lived with dinosaurs, right? At least at some point. Even if it wasn't after the flood, doesn't really matter, because we have a testable prediction come from Mark Armitage, who's been on Standing For Truth's channel. We've interviewed him. He made the prediction a very long time ago, and he said he was the first one to predict the dinosaur soft tissue would be norm, and we'd find it everywhere we look. That's what he said. He put it in writing. He put it in video form. Well, who discovered dinosaur soft tissue is Mary Schweitzer. He was right behind her and showed that the data isn't consistent, and he lost his job because of it. He's studied it for a very long time. And we found it in dinosaur soft tissue and dinosaur T-Rex. We found it in eggs. We find it in hadrosaur, dinosaur, duck-billed dinosaurs. We found it in fish. And guess what, everyone? There it is. Usually the most original bone is still present in dinosaur fossil. So it's still the original bone, right? So this is the problem, you guys. So they come up with these things that say, okay, everyone, it's no big deal that there's a blood cell right there, because you see, iron can saturate that, and iron is in the blood. It's called hemi-iron. And therefore, when it breaks apart, it can saturate that blood cell, and it'll protect it from breaking down. It'll also wrap around and saturate that other soft tissue over there on that side. Well, guess what? We've found 17 different types of soft tissue, not just blood and collagen, many different types of other things. But it also has a chemical process where the chemicals convert, okay? It's called racemization. And basically, life has left-handed amino acids. And over time, left-handed amino acids basically turn over until they're equally left-handed and right-handed. And that's what you have left. That process has an upper limit of 1 million years. So therefore, in all dinosaur tissue, because this is a chemical process that can't be slowed down by any known thing, except for maybe inside of amber, like in Jurassic Park, that amber handle pimp staff that old man had. Well, yeah, like in that, right? So the amber can slow it down, but racemization happens anyway. Iron isn't going to slow that down. So the racemization process of left-handed amino acids in life converting over 1 million years would be equal 50-50. So when we look in dinosaur tissue, we should find all of it equally 50-50. Do we find that when we look in dinosaur tissue? We actually don't. We actually find that the upper limit right here, 1 million years. We get 10 with 5 zeros behind it, and 10 with 6 zeros behind it. That's the lower to upper limit for racemization rates. So not doing too good. So racemization absolutely destroys dinosaur chemicals as blood, anything, from being really, really old. It's done. He predicted that we'd find soft tissue in a lot of things, and we have. So that's been confirmed as well. And I just throw in these sayings because I find them pretty funny. They admit that you need imagination to believe in these different things. So this is the interview that we had with him. I recommend you come and check it out. It's Dinosaur Soft Tissue with Mark Armitage. He's a beast, and we can get him on again at any time. Here's intelligent design predictions that were actually made on biochemical complexity, fossil record, distribution of molecular and morphology characteristics. And then, of course, Walt Brown, an animal, has over 60 predictions, mostly around in the 1950s and 60s. But here's his confirmed predictions. He predicted we'd find salt on Mars, ocean levels would be rising, carbon-14 in ancient fossilized bones, pooled water under hills and mountains, asteroids and rocks that are magnetized, Earth rocks that would be found on the moon, water inside of large asteroids, deep canals under the Bosporus, and I don't even know how to pronounce that in place. Rocks on asteroids and comets will be rounded. And asteroids will have low density. So all of these were predictions that have been confirmed already. And he's just thinking, but he's made 60 of them, right? So he's pretty much a beast when it comes to predictions. Obviously, I have his that we can cover some other time, which was based on radiometric dating, which he said we would be able to predict radioactive elements as well. And again, he got right. So unless you want me to cover some more, let me know when to stop, my friend.
Isn't that amazing that we've gone 2.5 hours of just nonstop predictions, retrodictions, refuting the critics? Maybe what we'll do, because I want to point out to the audience, guys, this is just a fraction. This is just a fraction of the overall evidence, the overall predictions. And Matt, very well-rounded presentation, brother. Astronomy, geology, biology, genetics, dinosaur soft tissue, a little bit of everything. And that's why I like to say, it's a great time to be a young earth creationist. It's a great time to be a biblical creationist in 2022. Why don't we wrap it up here, and then we'll do part 2, because I've got more slides I want to go through as well. And 2.5 hours goes by so fast when we're here dismantling evolution and confirming creation. Let me say this. We've just finalized the entire event, and it should all be scheduled in the next week or so. So September 5th to the 8th, and then the 9th, we have an evolution debate. So we're going to end the conference with a debate, with an epic one. So it'll be the 5th to the 9th, but technically the 5th to the 8th if we're just considering the presentation. So there's going to be 8 of us. Matt himself has been working on a must-watch presentation. It is going to give the fatal blow to evolutionism, although we've already given several fatal blows. So Matt's presentation is going to be titled Genesis Genetics. That's going to be a ton of fun. If you think this presentation was packed with information, wait till that one. Of course, I'll be giving a talk debunking the evolutionist favorite arguments. So that's going to be fun. And yeah, again, we got 8 speakers. So Dr. Jerry Bergman's going to be here, Sal Jardina, Joseph Hubbard, of course, Professor David McQueen, George Bond. T-Rock's going to be giving a presentation debunking isochron dating. CJ Cox is going to be giving a presentation countering compromise. So stay tuned, guys. This is going to be fun. This is going to be fun. So Matt, retrodictions, testable predictions, confirmed predictions, as well as novel future predictions that we've gone over tonight. So very comprehensive. Great job. Nearly 50 people still, and it's like, 7 in the morning. What we'll do, brother, is we'll also premiere this on your channel. I want to say tomorrow, but technically it's today. And then we'll do part 2 as well. So guys, here's what I want to leave you with. When you hear these evolutionists say that the evolution model makes testable predictions and the creation model doesn't, just know that either they don't know what they're talking about, which is probably the case, because 99.9% of these critics, they haven't really looked into the creation versus evolution controversy in great depth. They're just repeating talking points. Okay. It's the young earth creation model. It's the separate ancestry model that is meeting the gold standard of science and making successful testable predictions, and not the evolution model. So Matt, final words, final thoughts, brother, and we are going to wrap it up.
Awesome. No, I just hope everyone liked it. I kind of bounced around over topics because there's just so much to cover. I wanted to be a little bit on everything because, you know, as an audience, what if they like cosmic evolution? I don't touch on it. It's kind of like, well, I gotta at least hit a little bit of everything. And there's just so much to cover. Like you said, it's astounding that people say you guys don't have predictions. What does that even mean? It's just like, I don't even know what that means. It's just like, don't even speak again. You just don't even deserve to talk. It's just the dumbest thing I've ever heard. So like, I don't even know where to begin with some of these things. It's
right.
Pretty crazy.
It's why I chose out of all the ones that I could have elaborated on, cold slaps, and that still took half an hour. And then, you know, refuting Stern Cardinale, and while refuting him, see, here's why we love the biblical creation position, because we have so many what's called double whammies. You refute the critics, and by refuting the critics, you actually confirm biblical creation. You refute the critics, let's say on something genetics related, like recombination rates, mutation rates. And as a result, we demonstrate that our model makes testable predictions on DNA function, mutation rates, recombination rates, so on and so forth. So Cheryl says your part was amazing. Amen. Cheryl.
Thanks.
So everybody, thank you so much for tuning in. Please share this video around because we were comprehensive. If you're just getting here, make sure to watch it right from the beginning, because some of the questions we answered were, do biblical creationists make novel testable predictions? Can the separate ancestry model explain Neanderthal genetic diversity and phylogenetics? Yes. And make sure to watch the whole show to find out why. What about Dr. Stern Cardinale's objection to the created heterozygosity model, where he says the rate of intra-exonic recombination within coding regions of genes is too slow? He says we can't get the hundreds to thousands of alleles that we see for some human genes within the time frame allowed for the separate ancestry model. Is this a valid objection? The answer is no. And so please make sure to watch the whole video to find very comprehensive answers to these questions, including testable predictions. And Matt, your section was epic. So good. I appreciate it, brother. And to the audience, stay tuned for part 2, hopefully sooner than later, brother. All right. God bless. Standing for Truth and Matt Man are out.